All right, my name is Nate Richardson, and this is a presentation that I've got here on the water versus fire Earth. So, based on the universal model by Dean Sessions, and I started this a little bit ago and had some problems, and so that my last attempt turned into like a preview, 5-minute preview version, and we're gonna keep going here and see if we have better luck this time. So basically, we've got this idea that instead of a magma planet, we've got a liquid water core, solid ice inner core, and that instead of flowing around on magma, we are flowing around on water. Okay, a water, rock, slurry, and many large chasms of water. And this is going to be really important for when we're talking about the flood. Okay, where did all that water come from for the flood? And how was the earth made in the beginning? In the beginning, it says in the scriptures, it was by, the water in the beginning, and we'll talk more about that, I hope. So hang with me. I did a version of this at the Book of Mormon Evidence Conference. If you want to see, I think it's like a 45-minute version, and that was a lot of fun. So that was it's Book of Mormon Evidence Conference.org, I think, or .com, and it's the Rod Meldrum Conference over there. And this, it's been a lot of fun working with Dean on universal model stuff. He does the work and I just talk about it. So let's get started here. Water God versus fire God. So sometimes we don't realize how there can be moral implications to our science. And that's really what makes science interesting to me, is when I can relate it to morals and religion and the Bible, and how, okay, the creations do prove the creator, and we do have, evidence for God, evidence for the Bible, and that means that God is not just watching from afar or non-existent, but that he actually is intimately involved, and depending on how the people on the earth act, different things are going to happen in nature because of what God's doing for us. So, and I think that's why a lot of kids aren't excited about science these days, is because they don't we're not able to, in the public schools, to tie that in of, hey, all this science stuff is important because it's proving beyond a doubt that God is real and loves you, and the Bible and Jesus and all that is true. So let's get into this, because we're not here all night. First off, I have this about how we want demonstratable science from the First Presidency. Quote, "Our religion is not hostile to real science. That which is demonstrated we accept with joy. But vain philosophy, human theory, and mere speculations of men we do not accept, nor do we adopt anything contrary to divine revelation or to good common sense. But everything that tends to right conduct, that harmonizes with sound morality and increases faith in deity, finds faith with us no matter where it may be found." So we're not hostile to science, but we want to see it. Okay, show me the money. What's really going on? We want to see the science. We don't want to hear old professors rambling on about their theories all day. So let's talk about Hutton. He's one of those old professors that rambled on. A couple hundred years ago, this idea became popular that we have this magma-based fireball Earth. And you'll see that in demonstrations of the creation of the Earth. They'll say, oh, in the beginning, the Earth was this big fireball. And we're going to talk about how that's not what the scriptures say. They say it was a big water ball. James Hutton, he completely ignored the Bible and the deluge, and as a result, he was unable to clearly see what rock formations told him. He would pick up a rock and he'd say, well, I put this rock in water and it doesn't dissolve, so this rock must have not been made in a watery environment. What he didn't realize is that what the conditions were in the creation and in the flood are not creations that we observe today. So let's talk about some of the implications here. If you have the magma, we're going to talk about how that means you've got an old Earth and radiometric dating, which means you've got evolution, which means we are an accident and humans are not significant. It means there is no God, no Christ, that there is just death and eternal entropy, and this is all one big fairy tale of theoretical science. Now let's talk about the implications of the water Earth. There's easy to flood. Okay, if you were to take all the water in the atmosphere and put it down on the earth, you could cover the whole earth in about an inch of water. So you're not going to be covering much. You're not going to be baptizing the earth by immersion. You're not going to be covering those mountains just like the scripture said they were. So the water Earth versus the fire Earth. Okay, so the water Earth is going to help us see God and Christ, creation and purpose, life and resurrection, and demonstratable science. So, atheism needs evolution. Evolution needs old Earth. Old Earth needs radiometric dating of melted rocks. Radiometric dating needs magma formation of Earth. So, what we're going to see is the magma formation of Earth. This magma underneath is used as a way to say that's how the Earth was created. Now, it's a catch-all bogus to explain everything, but let's take a look here at it. Also, it roots back to atheism because it gives you that old Earth and it gives you that radiometric dating of things were melted, and now we got this clock going on with the melt here. And we're going to talk about how the melt's totally impossible. The whole Earth would be glass instead of quartz if that were the case. So, different arrangement of silicon dioxide. Instead of the crystalline, you'd have the slurry, okay, the metamorphic. Hutton completely ignored the Bible, right? Okay, so let's see here. Geology also is a mother science. The deep time based on old Earth influences biology, astronomy, cosmology, physics, etc. And so if we can take down deep time and old Earth by disproving that the Earth was made out of fireball and that it's made with magma and that it's all mostly magma in there and melted and fireball hell, that, you know, we're going to have some major changes. We're going to in all these branches of science, and we're going to be able to throw out atheism as the pseudo-science state religion as it is. One of the primary reasons magma remains so firmly entrenched in the theoretical framework of modern science is that the existence of magma is the foundation for dating the Earth. Okay, living water. Okay, there's a really quick. I want to pause and talk about the scriptural symbol of water. Living water. Elder Bednar says. Okay, let's see here. Bad battery. What's going on? Let me pause this and see what's going on here. If you want to pause these things, you can't. You can, and then when you need to, you can't. Well, let's see if I can redo this power source really quick. Okay, we're on. Sweet. Okay, I guess we're in it for the long haul because I can't pause this dang thing. So, let's talk about the scripture symbol of water. Elder Bednar says, living water is a representation of the Lord Jesus Christ and his gospel. And as water is necessary to sustain physical life, so the Savior and his doctrines, principles, and ordinances are essential for eternal life. Okay, and also the scriptures contain the words of Christ and are a reservoir of living water, which we have ready access and from which we can drink deeply and long. So let's wake up to what the scriptures have to say about science to help us combat atheism and save souls. Also, I thought of this interesting analogy the other day that our bodies are mostly water. I don't remember what the percentage they say, if it's 70 or 80 or whatever, but we might come to find out that the earth is too. And prophets have talked about how the earth is a living, breathing thing. So, all right. Again, here with the scripture pattern of being born by water, we're talking about how the earth was born by water too. So look at Moses 6:59 and Genesis 1:2. So Moses 6:59 says that by reason of transgression cometh the fall, which fall bringeth death, and inasmuch as ye were born into the world by water and blood and the Spirit, which I have made, and so became of dust a living soul, even so you must be born again into the kingdom of heaven of water and of the Spirit, and be cleansed by blood, even the blood of mine only begotten, that ye might be sanctified from all sin, and enjoy the words of eternal life in this world, and eternal life in the world to come, even immortal glory. And of course, Genesis 1:2 says, in the beginning the earth was without form and void, and darkness was upon the face of the waters. Okay, Apollo 8, the first humans to see Earth as a whole planet, they got up there and they read that. So they were actually, when they were reading the Bible, they didn't know that they were actually giving a scientifically correct description of the formation of the Earth as well. Earth's beginnings remain mysterious to science. So we're going to talk about, see this guy in zero gravity. He's out there. I don't know if this is International Space Station or what, but he's blowing these water bubbles, and in zero gravity, they're going to form a sphere, a perfect sphere. So imagine this little sphere as the Earth. Isn't that amazing to think about? And and look at them splitting in two, and that's gonna get you thinking about things for a long time as well. We've heard of different prophets saying that the Earth was bigger once upon a time. So anyway, there's a lot of neat properties that we're going to talk about. So we're going to talk about how the Earth's spinning. Um, you've got gravity pulling things down, and you've got a centrifuge spinning, pushing things out. And we're going to talk about a comet that interrupts that balance, which makes the continents kind of sink in, that because of the slowed spin. Okay, so the centrifuge isn't spinning things out as fast. We're going to talk about that. So here we have Crystals and Crystal Growing says, just how the Earth arrived at the form in which we find it is a question far from settled. Okay, and another quote here, the history of how Earth's interior evolved and how it accounts for many aspects of our planet's behavior remains largely unwritten. Taking water into account could help to explain a great deal more. We've got the larger bodies and smaller bodies here, the larger ones being more spherical, and this could also be more details on the topic of the water here. We'll also talk later about the different pockets on the asteroids and how they're evidence of a lot of water even in the asteroids, and how that's a big clue of what's in our planets. I was hoping when they threw the DART craft at that moon the other day, this is October of 2022, that they were going to see, maybe what with a secondary camera. I guess I don't even know if they had one, of if there was like, a geyser that would go off when it was struck or something, but I don't know that they got that information, or if the object was big enough, etc., that they threw at it. It was going pretty dang fast though. Yeah. So when you have the bigger objects, they're gonna be the more center of gravity to make things more spherical, which is another testament of the water interior as well. We'll get more into that. And yeah. Can there be liquid water in space? So we're talking about these planets as basically being formed by water and being largely these big balls of water. And so let's take a look here. At different pressure temperature combinations, you do find water in a solid or liquid when it otherwise wouldn't be. So let's talk about space, mainly a vacuum, right? Liquid water can and does exist in space. In a vacuum on Earth, water boils. Okay? Water in a vacuum on Earth boils. In cold space, the distant star radiant heat makes it a few degrees above 0 Kelvin. That's enough to make the water liquid at that pressure. Okay? And let's also note here that we've not seen magma in space. So, down with that. Okay, let's look at this little satellite here on the right. This there was a clouded lens on it because it was getting fogged over by the water vapor in outer space. And then when it turns to the sun, it got melted away. They thought, oh, our camera's broken, darn it, that was expensive. But then it turned toward the sun, and that light, that radiant heat, melted that off and cleared it up. So, wow. Vaporized it, I should say, because it condensed on the camera lens. So this was the SOHO satellite, designed to take images of the sun in orbit about 1 million miles from the Earth. The telescope was severely impaired because of water accumulating on its optics. Performance improved after temporary loss of control of spacecraft turned the telescope in such a way that the frozen water was melted away. This serendipitous event proved there was water in space. Okay, so let's talk a little more about radiometric dating being on the flawed premises of magma formation of Earth. So basically, if you don't have magma, you can't have the millions of years. You can't have the millions of years, of course, you can't have the evolution. And then, okay, wise guy, how do you explain life on Earth and Earth at all? And that's the thing, is when people try to say, oh, God used evolution, that's the biggest cop-out and ignorant statement, because the whole thing about evolution, the entire point of evolution, is to explain origins of life on Earth without intelligent design, without a superior intelligence arranging and orchestrating it all. It's the whole point is we need, it sounds like a fairy tale, and so they say, well, let's say it happened a long, 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 long time ago, and then, oh, I guess there's the possibility mathematically that this bizarre, thing could happen. Well, we're going to take away that long, long, long time ago and expose it for the fairy tale that it is. So, with radiometric dating, okay, no matter how sophisticated our technology is, no matter how much precision, the data is bunk if the theory that it's based on is bunk. Okay? Now, and then even when we do use our radiometric dating, the absolute dates are not so absolute. So, um, uh, one date on a melted rock gave 1.9 billion, another reading 2.5 million, another reading 21,000. So yeah, there's a lot of problems here. So we're not going to rely on this, and we're going to show the water-based Earth means, no melt means no radiometric dating. We'll get more into that. Okay, so historical and scientific Earth ages. Um, the yeah, the geological time scale. Okay, we're going to be talking about how that was bunk. I also did a lecture before this which talked more about fossil formation, evolution, and so forth, and combating some of that. So you might want to check that out, and that'll help with some backstory of this. The layers, of geological time were never supported by any real foundation. We've got the universal flood that's going to talk about the extinction of the dinosaurs. It's going to be making all kinds of clay and sand and minerals all around the world. And that's just a whole big topic that we'll get into later, the flood stuff. But so, yeah, historical records show the creation of Earth, 7,000 years of creation, because the scripture says in Genesis, it says there's 7 days of creation. And then in 2 Peter 3, verse 8, it says, well, a day for the Lord is 1,000 years. So we're going to consider the creation days as 7,000 years, or in other words, 7 God days. So then you add that the Adam and Eve were like 4,000 BC. So that's from then to now is about 6,000 years. So we're talking about 13,000 years total for age of Earth right now. So, and then you got all these other different people who think they have the right date. And sea level folks, they'll say, oh, well, it's a greater than 2 billion years old Earth. Temperature folks, based on cooling of sun and Earth, they'll say, okay, well, it's somewhere between 75,000 and 1.3 billion, and somewhere between 4 million and 500 million. So that's pretty precise. And that was in the 1700s, 1800s, when they were working with that stuff. Okay, orbital physics, 1800s, 1900s. They're saying 10 million to 3.7 trillion years old. Ocean chemistry, okay, late 1800s, early 25 million to 2.3 billion. Erosion and sedimentation, those guys were saying 5 million, 3 million to 5 trillion. That's a pretty big window. Radioactivity, like what, who cares, right? Radioactivity, the different types of radioactivity that they've been using in the 1900s. So they were saying 1.6 billion, and it just kept, getting bigger. And anyway, they've kind of settled on 4.5 billion. It's kind of fluctuated there, but again, it's the fairy tale that is totally unbelievable, and so it gets a lot of time. Anyway, it's pretty crazy how a lot of this can be so deceptive, Okay, Michael Shermer, Scientific American in 2010 says, so it is time for scientists to respect history as a science, and for historians to test their historical hypothesis by the comparative method and other techniques. So they're saying, yeah, we have no clue what's going on. So we probably need to take the historical records seriously and see if we can get, anywhere close to reality here. Okay, here's some supporting evidence for the water model from the Chapter 5 Magma Planet Pseudotheory stuff from Universal Model. There's one chapter, it's Chapter 5 on Magma Planet Pseudotheory. It's about how no, our Earth was not made from lava, and it's not going to be, it's not continuing to be lava. And then Chapter 7 is the hydroplanet, which shows more evidence for, okay, well, if it's not magma, what is it? And obviously there's a ton more than I'm getting into on this lecture, and I can already tell this is going to go a while, so I'll try to keep moving right along. Okay, let me make sure that we're still rolling here. I think we are. Okay, let's keep going. So what causes plates to move if not magma, if it's not these convection currents and stuff? Okay, well, we're going to talk about the flood comet that many scientists have talked about, and we're going to talk about how, in the scripture it says, as in the days of Noah, it'll be at the end. Well, at the end in Revelation, it talks about this comet coming and messing things up, throwing things off to make these catastrophic major upheavals, right? So the days of Noah, same thing. So pretty darn good theory about the flood comet. Okay, we're also going to talk about tidal forces, how the pull of the moon and the sun also makes the plates of the Earth's crust move around. Okay, and so Peleg, it says the Earth was divided in the days of Peleg. I've heard some different theories about that, but I really don't see why we need to get away from just the Pangea into what we have present day with the continents separated. And maybe it took, a couple hundred years for this all to settle down and get to present day. But either way, I think the Peleg idea is just fine with this. It isn't difficult to imagine how the continents once fit together in a one supercontinent, and a multitude of evidence confirms this was the case. The universal flood mechanism powered the Peleg drift that divided the great single continent known as Pangaea into its present-day condition. Perhaps before the flood, there wasn't much volcanic activity or mountains due to a coherent plate system. Now, we do hear of mountain formation in the beginning. I'm pretty confident there was mountains before the flood, but what we're going to talk about is that at the, because you've got an idea we introduced last lecture was hypertherm, which is hydropressure thermal, so hot water pressurized, and it's the flood was not just water; it was hot water. It was dang hot, and the plates were generating so much frictional heat in this movement, in the buckling of the crust. The Pangea, when all the continents were together, it wasn't, 7 continents. It was all one thing, and it broke. That's what happened, and then they spread apart. Now, continental drift, that's saying over millions of years they drifted apart, but that's not what that's not the case. This happened quickly. So let's see here. The flood trigger. Now, I don't remember how old Peleg was before he died or anything. That could be interesting as well. But anyway, we're not going to obsess about Peleg right now. But so the flood-triggering comet came near the Earth to disrupt balanced forces acting on the Earth, making major disruption, breaking up Pangaea. This continued tidal forces acting on the Earth continue to create some movement of plates. It is not magma ocean moving things around arbitrarily. Something we're going to talk about is the correlation of earthquakes and lava flows, how the earthquakes, and they can actually be predicted. More and more we can predict earthquakes because we're finding out that they're like the ocean tides. There's these micro earthquakes all the time as well. It's a repeating regular pattern caused by the tides, and scientists are pretty fussy about that still. They don't want to put that connection together. And there's some pretty big implications and reasons why. You could say, well, if we can pin down that a lot of the earthquakes are being caused by tidal forces, like from the sun and the moon, like our ocean tide, and that's, making it so we can better predict our earthquakes and all this. Isn't that like a good news? Why would we resist that? What's the agenda to that? Well, it all ties back to the magma. If it's not the magma flowing around underneath that's moving things and causing these earthquakes, then, and pushing the plates around, then their magma's gone. What we're going to find out is that to explain nature, you don't need magma over and over. You just don't need it. And it's kind of crazy because you don't need it. So it probably doesn't exist, right? It's like when Lavoisier was talking about phlogiston. He's like, we don't need phlogiston to describe nature, so it probably doesn't exist. And it's kind of funny because it's almost like magma is the new phlogiston. Isn't that funny how it's just another one of these scientific, alibis that is being used? Well, right now you're saying, oh, okay, Nate Richardson, you're crazy. What are you talking about? And hopefully, as I give some more evidences in this lecture, you'll see a little bit more of why we can make these claims. Because nobody's been down there. Nobody's seen the middle of the Earth in about 9 miles, a little more than 9 miles, as far as we've gotten. And we're going to talk about how the deeper you go, it's getting wetter and colder. You've been in a cave, right? It's cold down there. So we'll talk more about that later. When you do have a hot underground mine, it's because it's by a fault line. So we're going to talk about a major emphasis on faults generating friction heat, and that even generating lava and local lava in volcanoes, not this magma lava. So let's move on. The basic premise of volcanology with magma or water. So let's take a look at this. So tectonic plates, the good analogy is a egg with its shell that's cracked. That's kind of what the Earth is like. It's got these plates on top. It's like a piece of paper on a basketball. The Earth's crust is really thin. And that's another thing that we might talk about, is that how crazy is it to think that underneath us is all this lava when, we've just got this sheet of paper between us and this big fireball. Okay. So anyway, so with magma theory, you'd say it's the plate movement is from magma pushing things, but with theory we're going to talk about, it's the hydroplanet theory and so forth, that the continued movement of plates is caused by tidal forces pulling on the Earth. So what is an earthquake? Where's lava from? This, yeah. So yeah, remember an earthquake, it's basically let's say you break a pencil in your hand. Okay, it kind of hurts, right? Well, if you were to slow that down a lot, you'd see that the pencil it shakes when you break it, because it's all that pressure build up, and then it breaks. Elastic rebound, and that's like what happens in an earthquake on a big scale. It's crust of the Earth, it's rock bending and breaking. So magma theory would say that oceans exist under the crust and supply the volcanoes. Okay, that magma oceans, that is, and that they supply the volcanoes. But in the theory we're going to talk about, let's remember that pencil analogy, how you snap it and it's painful. Okay, there might even be some heat. This breaking involves extreme pressures, which liquefy the rock, creating local lava. All right, I'm going to break one more time here. See how we're doing with our business. Okay, looks like we're doing good. Ooh, 30 minutes already. Okay, hang with me. This is great. So, all right. Yeah. So let's get back to work. Let's talk about the dense iron core. Okay, no and no. Okay, not dense and not iron. Cavendish's 1798 density calculations had fatal assumptions. We aren't in space, so the experiment was restricted by the air and influenced by Earth's gravity. The the attraction of the objects in his apparatus should have been measured in a vacuum in low gravity to better simulate space that our Earth is in. So Cavendish does these experiments and he fails to take into account these things, and so his density calculations way off. So truer density, okay, instead of the gosh, it's been a minute. What is it? 5.52 grams per cubic centimeter that Cavendish suggested. Okay, um, so we know that as the average density. Okay, the surface rocks are about 2.7. The crust, okay, that's about the density of that. That's pretty easy, right? Pick up a rock and okay, what's the density? And Cavendish said, well, let's see, I'm guessing 5.52. So he was thinking that whatever is inside the Earth was more dense. So they said, well, pure iron is 7.87 density. So that accounts for your approximate, 2-ish difference of grams density. So that's why they're saying whatever's inside the Earth is heavier. Okay, and that so we've got this 2.7 crust. Well, the average is 5. Okay, that must mean that whatever's down there is heavier. And they say, okay, well, how about iron? Iron's heavier. Okay, it's higher than 5. Okay, and so now there's a few problems with that. Pure iron doesn't exist in nature. Okay, that's one of the big problems. You're not just going to have this big giant ball of iron. Like, what the heck? And that's another thing that they do with their magma stuff. They say, oh, all the heavy stuff, it fell down, it went deep. But we're going to talk about how the heavy elements are usually at the surface anyway. Like, there's plenty of uranium ores at the surface, so that doesn't work. So now, Dean in has done some density calculations of the Earth with better assumptions that more resemble space, and talks a little about that in Volume 1. Volume 3, which we're praying that he gets out, which is well underway, talks a lot more about that, but how the true density would be around 2.3. Now, as the average density. Now you'll notice that his calculation for the average density is lower than the crustal density of 2.7. So he's saying whatever, based on these updated figures, whatever is below the crust is less dense than the crust. Okay, this is where we can start to make some sense of water down past the crust. Okay, ice water and salt and liquid water, and of course lots of rock. Okay, so let me read this scientist O.M. Phillips. He says, so let us make the tentative hypothesis that the core of the Earth is made mostly of iron. Remember, however, that it is still tentative. Should we discover facts with which this model cannot be reconciled, it will have to be discarded. So, your kids' textbooks, they make it all seem like this is absolutely how it is, and that's always been how it is, and we're totally confident, and nobody mess with us. But they're not confident about it. It's crazy. This stuff gets shoved into your textbooks. So, yeah, this is a relatively new theory, this magma Earth, and so is evolution theory. And boy, they are the gospel of modern science. So, let's talk about another really important point here. Water ice doesn't melt when it's under pressure. Okay, and what is iron do under pressure? We don't even know. Okay, is it stable under pressure? We don't even know. Because you look down at the deep in the earth and you're like, man, that's a lot of pressure. Well, guess what? Water ice doesn't melt when under pressure. We know through seismic waves that Earth's core has both liquid and solid components. Okay, we know that. It's obvious. The debate is, what is the liquid component? Is it magma or water? Okay. We also know that H2O ice proved in recent experiments that ice forms a stable crystalline structure under high pressure. Says Reviews in Mineralogy, quote, the prototype system is H2O ice, where recent experiments have shown that a symmetric hydrogen bond state of ice forms at 60 GPa and persists to at least 210 GPa. At these high pressures, ice did not melt even up to 50 degrees Celsius. Okay, so you've got cranking up the heat 50 degrees higher than where it usually melts, but you get that high pressure and it's not going to melt, okay, at those higher temperatures. So, now let's talk a little bit about the iron core, okay? Just as liquid water becomes solid ice or gaseous steam at certain temperatures and pressure, so does iron. What did researchers from the Mineralogical Society of America find? To the extent that the inner core consists of pure or nearly pure iron, its crystalline structure is determined by the iron phase diagram. While there has been considerable progress in experimental determination of the phase diagram at pressure approaching the inner core, the stable phase of iron at inner core conditions cannot yet be uniquely identified on the basis of phase equilibrium measurements. Another report states the stable phase of iron at inner core conditions is unknown. It is unknown because, as far as anyone knows, it does not exist. Although stable iron phases exist at low temperature, empirical evidence from actual experiments proved that at high temperature and pressure, iron is not stable. We find, quote, we find no evidence for phases other than those long known from low pressure work, close quote. Okay, so let's talk about another crazy topic, which is that heat destroys magnetism. Okay, now they're saying that we have this magnetic field around the Earth because of the heat, the magma in the middle of the Earth. Well, guess what? Heat destroys magnetism. If you want to disrupt a magnet, heat it up. It loses its magnetic components. Okay, so let's read a couple scientists on this stuff. And again, go to Dean's book. I've got the page numbers for the references and all this. That's one of the things that Dean made a big emphasis on doing when he wrote Universal Model, is that he didn't just say such and such journal says this and paraphrasing it in his own words. He actually puts the whole quote in there so that you're not having to go and supposedly look up 500 essays, academic articles, but he actually puts the quotes in there. And so it's really great. Anyway, let's read a few. So, unfortunately, although a good description of the magnetic field can be given if we assume a permanent magnet at the center of the Earth, this model has a fatal defect. Laboratory experiments show that heat destroys magnetism, and materials lose their permanent magnetism when temperatures exceed 500 Celsius. Material below depths of 20 or 30 kilometers in the Earth therefore cannot be magnetized because of the temperatures are too high. Close quote. So this is why another petrologist says, magmas properly belong to the realm of theoretical petrology, and considerable uncertainty still shrouds the outer core and inner core from our complete understanding. Okay? And they make it sound like they're so confident, but they're not. Again here, quote, because so much is known about planets that are light years away, one might assume that science has unearthed everything worth knowing about the one beneath our feet. To the contrary, Earth's most inner reaches remain in many ways as mysterious as the cosmos at large, close quote. And, quote, the question of where magma comes from and how it is generated are the most speculative in all of volcanology. We cannot see to any appreciable depth below the surface of the Earth and have few direct measurements of the nature of the materials in the Earth's interior. So, long story short, the origin of lava has never been proven, and we're going to talk about how, um, you know, the theory that people are pushing these days is that there's a big ocean of magma down there, and we tap into that every now and then for a volcano to happen. Now, speaking of tapping into it, industrialists have tried to tap into it to get this awesome, inextinguishable energy source, but nope, can't find it. Just can't find it. Well, it's because it's not there. Okay, no one has seen it. No one has been able to find it, based on despite dumping in, and they're still trying to find it. They're still trying to tap into it, and they're still failing, and they're still wasting money. Um, okay, so yeah, heat annihilates magnetism. Chew on that. Heat destroys the electric nature of quartz. So any quote, any growth process for quartz must be effective below 570 Celsius. The alpha to beta quartz transition, if it is to produce the piezoelectrically useful alpha phase. The melting point of silicon dioxide is above 1700 degrees, ruling out melt growth. So basically, this is the deal, folks. Earth's crust, okay? We're talking predominantly quartz-based rocks and minerals. And we know that these are piezoelectric in nature. You compress them, they're going to generate an electric charge. You stretch them, they're going to generate an electric charge. And this is used all over the place in technology today, and it's really obvious. But what we're saying here is that if you take that quartz and you heat it up above 570, it's going to lose its piezoelectric nature. Okay? And if this all came from a melt, guess how hot it has to be to melt the silicon dioxide and quartz? 1700. Okay? That's like triple the threshold that we could reach. So it didn't come from a melt, folks. It came from a heated, not that hot, but heated pressurized water situation. And we're going to talk about how when we've got these even fossils, you've got these minerals being forced into the bones or forced into the wood, and it becomes a rock. But they're not just going to leach in there. There has to be that unique pressure situation, and the water, okay, and the mineralizer, and anyway. So at World War II, with the extra need to make watches, they found out how to make quartz in the lab. Guess how they did it? Oh, they melted stuff. No. They used water, not melting. Okay. So, quote, the quartz cannot be grown from a melt because the piezoelectric phase necessary for formation of electronic crystals is not stable at the melting point, quote. And again, quote, at a temperature of approximately 573 Celsius, quartz transforms from alpha to beta quartz. During the transformation, most of the piezoelectric characteristic is lost, rendering beta quartz unsuitable for the manufacture of crystal units, close quote. Okay. The electric nature of quartz also explains the magnetic field around the Earth. Okay, the Earth tide generates this field daily. Again, no magma or iron core is needed. So what is Earth tide? Well, every day the Earth, just like how the tide water goes up and down, well, you'll see in other planets, and we're going to talk about this, we're going to use the case of Io, Jupiter's moon, and other places, that every day the crust of the Earth goes up and down. It's kind of cool, because we mentioned earlier about the Earth being a living, breathing thing. It's like your chest going up and down every time you breathe. Well, basically, the Earth goes up and down 8 inches every day. So that's called Earth tide. It's when the Earth actually moves. And like we talked about with these piezoelectric rocks, when you compress them or stretch them, they're going to generate that electricity. So that's what causes this field around the Earth, not the iron dipole magnet in the middle of the Earth from some supposed iron in the middle of the Earth. So I know all the geologists are falling over dead in their chairs right now because we're taking down some big theories here. Okay. And I have fun with this, and I enjoy this. I guess I get a little sassy sometimes, but you gotta let me have fun with this. And, is every last single thing that I'm talking about, like, beyond a doubt, extremely, gospel truth? I guess not, but um, we're doing the best we can, and let's be open to some new ideas. Okay. So, here's an experiment you can do with piezo electric rocks. You can compress them and use a voltometer to measure what's being output. Okay, and there's this chart here. You can use all kinds of different rocks: river rock, chert jade, quartz, moss agate, sandstone, ocean jasper, petrified wood, quartz cube, glass, galena, copper. Okay, now the copper is the control. So anyway, you've got all these different millivolts from this. You've also got there's this quartz film that you compress it and it lights a bulb. Okay, there's no electricity before the movement, and then when the quartz film is flexed, electricity is generated, similar to the piezo field generated by quartz rocks when the crust is stressed by earth tide. Okay, so basically, yeah, a lot of folks don't know about this, and it's, you know, kids can do it, simple. And if we say there's no magma and no iron, we're going to need to explain the field around the earth. And we're going to talk more about that. And we're going to talk more about how, the quartz, instead of glass everywhere, we've got quartz. So this is showing that the earth was not from a melt and that all these rocks were not from a melt. Okay, and here's a picture of the Geofield, all these different fields, and guess where they're the strongest? Around the continents, because that's where you have the most piezoelectric pressing and charging. So, yeah, it's not just one giant magnet dipole, it's several, and they're most intense around the continents where there's the most piezoelectric flexing going on of crustal rock. Okay, your crustal uh, continental crust is about 6 times thicker than your ocean crust, so there's a lot more rock to compress and release there. Okay, let's move on. So here you've got another little demonstration of the multiple fields instead of just one big dipole, and that's what we're going to have. Is there's not just this giant ball of or giant bar even of iron in the middle of the earth. There, the Geofield or magnetic field is from a series of different areas from the crust. So, and we can demonstrate multiple fields as we see here in this image. Um, the generation of planetary magnetic fields is an unsolved problem that has been with us for a long time, says Margaret G. Kvivelson, astrophysicist. So, let's talk about magnetic fields due to tidal forces. Okay, Venus has no moon, and so it has a very weak energy field. So again, Venus is not getting as much tidal force because it has no moon. Okay, that's why it has a weak energy field. Okay. Okay, tidal forces charge piezoelectric crustal rocks, generating an electric energy field. The discovery of Ganymede, Jupiter's Ganymede magnetic field, shows that something needs to be modified in the accepted description of the evolution of the solar system, close quote. So here's Ganymede. First off, it's very far away from the sun, so we're colder out there. Second off, it's quite small. And so if the idea is that the Earth was and other bodies were made with the magma, and then over time it cools down. Well, this is a lot smaller, so it would have cooled down already. And a lot of the times, their go-to thing of why something has a magnetic field is because it has big iron inside the magma, and the and this shows way out here in Ganymede that this is a small distant object that still has the magnetic field. Now, why would it have a magnetic field, kids? Well, because it's got all that pulling going on. Okay, it's got all the other moons of Jupiter, and we're getting a lot of generation, piezoelectric generation here for that field. Okay, this is a diagram of the Earth's magma dynamo and movement of the energy field's north pole as envisioned by NASA. The problem is that the ocean of iron, shown in orange, and the direction of the pole movement are incorrect. Okay. If the heat is about as hot as the surface of the sun, it would destroy the energy field, okay, which is what they claim it is. Moreover, the circular motion of the field's north pole is also incorrect. Okay. All right, let's go on to the geofield continent connection. We talked about this a little bit before, how the geofields are strongest around continents where there's more to work with. Okay. So it says the one fascinating piece of evidence supporting the true creation of auroras is the coastline aurora evidence. 3 investigators from University of Iowa evaluated approximately 9,000 images taken by the Polar Visible Imaging System satellite in 1997. They found the following, quote, humans are not alone in showing a preference for coastlines. So these images are USGS and NASA. They show field strengths during 2000. The areas of highest strength, red in the upper left globe, are over the land masses of North America, Russia, and an area south of Australia, whereas the area of low strength is circled in yellow. The area of lowest field strength corresponds to the area of lowest in continental landmass. This is not a coincidence. Large landmasses produce the planet's piezo field because of elevated concentrations of piezoelectric rocks in the crust. So, the lowest concentration of continents, okay, is where you have the lowest energy field strength. Okay, so no coincidence there. The increased strength of the Earth's energy field over large land masses is not a coincidence. It's a direct result of the piezo field nature of Earth's energy field. We're talking a lot of rock, folks. We're talking a lot of pressure. So this is all very realistic. Let's talk about weather influenced by crustal friction heating. Atmospheric weather begins with earthquake heating in the crust. So the water cycle, it says that the only heat source is the sun, but a new and improved water cycle in the UM talks about how you have the crust heating, and that has a massive role in weather. You got these clouds that form in a matter of minutes, okay, and these cumulus clouds, we call them hycotherm formed clouds. Hycotherm is high as water, qua is quakes, therm is heat. So there's these the idea that we've got earthquakes, and the water which is in the crust is vaporized by these earthquakes and quickly detected by a new massive cloud. The puffy cotton ball or cauliflower-like cumulus clouds are one of the 2 main types of clouds. They form primarily over the land and often have flat bottoms because of their rapid development as vaporized water condenses once the air mass reaches an altitude where pressure is reduced. Cumulus clouds are not evaporative clouds. They are endovaporization clouds that formed from hycothermal activity. This is why they form and change rapidly, often within minutes. Gravitational friction from earth tide and other seismic events produce cumulus clouds by vaporizing and releasing water from underground aquifers. Okay, if magma existed, it should have been tied to weather, but it does not exist, and no connection has ever been made because it doesn't exist. Okay, so the first law of weather is that Earth's weather is changed by hycotherms. The second law of weather, that hycotherms are changed by gravitational astronomical cycles. The third law of weather, that earth tide, atmospheric pressure, and the geofield are directly connected through gravitational astronomical cycles. Okay, we've got earthquake clouds. You can predict earthquakes by clouds. I know this is sounding kind of crazy, but hang with me. Hang in there. And so you'll see a lot of cool evidence for this. We don't have time to break it all down, but you've got evaporative clouds, cirrus and stratus clouds formed from evaporation. And then you've got earth tide clouds, which is cumulus clouds formed from minor endovaporization. Then you've got earthquake clouds, which is clouds formed from major endovaporization. Yep. So let's go on here. So, tornadoes. Scientists still do not know the exact mechanisms by which most tornadoes form. Why would both of these tornadoes occur in May during 1981 and 1999 in Oklahoma? Okay. They appear to be at the same time of year and the same locations. Why are they associated with cumulus clouds, and why do they have a strong vertical uplift? So that we talk more about in the weather model, and how these phenomena are all tied into what we've been talking about. They're intervals in tidal forces. They cause interval manifestations in the weather. Okay, so they're like, why in blazes is this on a regular basis, like the tides and these regular patterns? And this term earthquake season or tornado season, okay? So unpopular ideas. Let's move on. Okay, we talked a little bit about how the idea where there's these radioactive heavy elements, and when the earth was a melt, they sunk down to the middle of the earth, which makes it more heavy, and they're trying to explain this theoretical iron and so forth that they've got. Well, you know, according to this, we should have radioactive lava, okay? Because if the lava is coming from way down deep, and the and it's circulating, it's in these supposed convection currents circulating around now. So why don't we have radioactive lava? We don't have radioactive lava. It's not radioactive. Okay, so also they say there's this hot uranium. Okay, well, we can hold these uranium ores in our hand, and it's not hot. Okay, so another thing they try to do is they say, oh, well, it's magma because there's all this hot uranium. Okay, it's actually not even hot. So what are you talking about? You know. Also, you find it at the surface. So why do we have these heavy metals? If there was this melt, wouldn't the heavy metals have all fallen down like they say they would into the deep? Okay, well, here it says, yeah, we are 4.5 billion years supposedly after the Earth's creation, and it's still hot due to radioactive magma convection. Okay, quote again, why should the radioactive materials be concentrated in the surface layer? The element concentrated in the surface layer. The elements involved are very dense. If the Earth cooled from a liquid mass, one would expect them to settle to the center, but no. They are apparently found almost entirely at the surface. Why? Close quote, why indeed? And we're going to talk about how a lot of these ores were made during the flood, and the flood impacted and formed things on the surface, and that's why most fossils are found near the surface as well. Because fossils are things that were organic and they are now rocks, and they are God's signature of the flood. They're a signature of his judgment on the world. Again, we've got the involved God, not the absent or non-existent God. Okay, so we've talked about how, well, everybody will agree that there's liquid underneath the crust of the earth, but what liquid? Okay. In a 1911 encyclopedia, it said, quote, the old idea of universal magma or continuous pyrosphere has generally been abandoned, close quote. So even back then, we're getting away from the idea. There's more and more problems with it being universal magma. Again, quote, in discussing the cause of volcanicity, two problems demand attention. First, the origin of the heat necessary for the manifestation of volcanic phenomena. And secondly, the nature of the force by which the heated matter is raised to the surface and ejected. Okay, so we've got these different maps here, and you'll see that the direction of these earthquake waves turns when it goes into a different medium. This is pretty obvious. Okay, so this is how we know we've got the liquid outer core and the solid inner core. Okay, and the rocky mantle. Okay, well, that's those different states of matter we can agree on, but what they are made of is where we disagree. So we've got these, the S waves and all this. They travel differently through solids than liquids. So we've got it nailed down that there are these different states of matter. But science assumes the liquid is magma because of the theoretical high temperatures at the core. Again, theoretical. So we'll be talking more about this. Okay, we can explain the origin of the heat needed for volcanic phenomena, and we can explain the nature for how it's ejected. Okay, when you've got the friction heating from the movement of the plates in a catastrophic event, then you've got a lot of heat generation enough to where you've got rocks that are melting, okay, and they encounter the underground aquifers and water chambers, and they turn that water into steam, okay, which is 1,700 times the volume. So pop, like a popcorn, right? When you put popcorn in the microwave, it pops. Well, that's because there's a little bit of water in the pop kernel, in the corn kernel, and then that water vaporizes, and so it expands, boom, into your popcorn, and boom, that makes an explosion. And so you've got this 1,700 times increase, and this gas is going to shoot things up to the surface, you betcha. And we're going to talk about dramatic hydro fountains, and how the main thing that comes out of volcanoes is actually water, not only water vapor, but liquid water. Okay, and that's where you get all the mud and all this. And it's not just from the roof of the volcano being covered in snow. That is way under, does not account for all of the mud flow by any stretch. Okay, the water that would be needed to create that mud flow. And I think that'll come up later. I hope you guys are enjoying this. I think we're in for the long haul here, but we're moving along. Friction at faults makes lava. Okay, so you rub your hands together and you get little pieces of your skin. That's skin lava. Okay, little burnt skin pieces coming off. Does magma cause earthquakes, or do earthquakes cause lava? Okay, so mainstream idea is that magma causes the earthquakes. It's slushing around down there. It's convecting in these currents, and it's this little lava lamp, and it's moving around the plates, which is gonna make earthquakes, right? Well, actually, we don't need the magma, okay, to move things around. We've got the tidal forces that can move things around. Okay, we've also got the comet that did a nearby pass at the time of the flood. Very strong theory, which threw things off and would have caused a buckling of the crust, snapping everywhere. And this is major plate movement. And man, when you snap a big old thing and there's billions of tons of pressure on it, you betcha it's gonna be way hot enough to uh, melt the rock into a lava. And so the idea here is that we have local lava creation. Okay, lava often flows along fault lines. There's a picture of that. Also, we have frictional welding. Okay, in a fraction of a second, you can weld things together by friction generating enough heat to weld these metals together. There's a couple neat diagrams here. So let's look at this. Frictional melting can occur if the stress involved in faulting are sufficiently high. Despite these studies, frictional melting is not generally regarded as an important process during earthquake faulting because of the uncertainties in the stress levels. However, we've seen things get much hotter than is required for melting of most silicate rocks. The Bolivian quake was said to have upwards of 52,000 degrees Celsius. And how much do we need to melt most silicate rocks, you remember it's 1700 degrees. So we're like, gosh, way higher than, was that 25 times as, as hot as we need to melt it. So a lot of times people say, oh, these earthquakes, doesn't generate enough heat to melt rock into lava. It does by like 25 times more. So another quote here: the possibility of frictional melting during faulting has been suggested by several investigators. Okay, and there's some diagrams here of how this can be local generation and the water aquifers, etc. Okay. Yep. Okay, let's talk about Io. This is an exciting thing. Io is in this tug of war by Jupiter and other moons, Ganymede, Callisto, and Europa, and it's the most active place, volcanically active place in the solar system. And so, why? Okay. Well, first off, we beg the question because it's far away from the relatively far from the sun and relatively small. Okay, but so scientists they have to admit that, okay, yeah, it's from tidal forces. Okay, and the bulge daily on tidal force bulge, we would say earth tide if it was on Earth, but I guess we call this Io tide. But it's not the ocean tide. It's the actual crust of it is going up and down 100 meters. Okay, 100 meters. So it's no wonder that there's these mega lava flows and stuff, because they're making so much racket with all this bending and moving and earthquakes, melting things, massive friction heat. So what's ironic is they'll allow this kind of stuff for Io. Obviously we're not as volcanically active as Io, but why don't they allow this stuff for Earth? Okay. Quote, NASA says, quote, solid tidal bulges on Io are about 100 meters high, taller than a 40-story building. Okay. And quote, all this, another quote here, all this bending causes heat to build up inside Io. Io gets so hot inside that some of the material inside melts and boils and tries to escape any way it can. So it blows holes in the surface. That's what volcanoes are. Some on Io have shot their hot gas plume 300 kilometers, about 200 miles, into space. So bingo, bingo, that's what volcanoes are. It's the melting, the vaporizing, the boiling, gases trying to escape and pushing their way up through a hole, making a hole, pushing through the faults. Okay, astrophysicist says a model of Io's core is that it's heated from the outside by tidal flexing of the layers around it, rather than being heated from the center. Close quote. Why don't we expand this idea to more than Io? Okay, so let's take a look at this. Earthquakes and volcanoes, plate boundary collisions. So, only about 10% of the world's earthquakes occur along the oceanic ridge system, and they contribute only about 5% of the total seismic energy of earthquakes around the world. In contrast, earthquakes occurring where plate boundaries converge, such as at the trenches, contribute to more than 90% of the world's release of seismic energy from shallow earthquakes, as well as most of the energy from intermediate and deep focus earthquakes. This is the Ring of Fire along the Pacific Plate and so forth. Basically, all these little black dots here are earthquakes. The red dots are volcanoes. And so you're seeing a mega correlation of where there's earthquakes, there's volcanoes. Okay, this is where we stroke the chin and wonder what is going on here. Well, the earthquakes are causing the volcanoes. Okay, the friction of the plates. We're going to get into subduction and how that's got a lot of problems. Subduction involves a plate collision where the lighter oceanic plate sinks down deep into the mantle and gets deep, deep, deep to where it's melted by the magma. Okay, magical magma melts it, and then it comes up, up, up as a volcano. Okay, well, you don't need to go deep, deep into the fairyland. You can be right on by the crust and get this going. Okay, let's move on here. Okay, now, we could say, okay, well, that's nice where the plates are hitting each other. Okay, well, that's going to be creating some obvious friction. Now, what about when you're not by a plate line? Well, let's look at Yellowstone. Okay, it's hundreds of miles from a plate boundary. Okay, so we're not gonna, where's your subduction to save the day now? Okay, so guess what? Yellowstone is hot, but there's no magma, there's no boundary crack to allow magma to come up from the mantle. So, why is it so hot? Fault lines. Look at all those red fault lines right there, shown in red. Okay, we're going to take a look at this again, I think, later. Okay, let's talk about deep earthquakes. This is another mysterious thing. Deep earthquakes, we've got deep earthquakes that happen, and the scientists are pretty stumped about this because it's so deep that it would be more fluid, this magma area. And, as it's said here, it is difficult to fracture honey. So for earthquake, remember the bending pencil? You've got to bend it and snap it. Okay, so so the scientists say, at present, the mechanism for these very deep focus earthquakes remains speculative. Okay, now let's talk about some possibilities for what's going on down there. First off, we have rock, okay, and not just magma. Second off, how about solid ice, mega chambers of solid ice, and channels and all this? Man, it's so cool. I'm so excited to see more of this. And so we've got deep earthquake ice fracturing, explaining a long-lasting enigma in geology. Okay. Here we've got a tomography of Central America. We've got this cooler area going way down in the mantle. Okay, this is where we'd have large amounts of water. Okay, now near the surface, it's mostly near the surface where you got the hottest. Okay, now we can have water, we can have ice, we can have all kinds of stuff. We can have rock, so we can have different temperatures as we're going down. And look at this. The earthquakes along here, we've got the heat as the upper area, not the lower. So where's the plume? Where's the chamber of magma there? So okay, we're going to look at some more tomography a little later. Okay, let's try drilling to find magma. Yep, we've tried over and over. We can't find it. And we're still trying, and we're still wasting money. Okay, we talked about this. Alfred Duba says, the more we drill, the more we find out how little we know. Okay? Failed this where they were looking for this. It failed to show up at 3 kilometers, at 5, okay, 7.5. We still haven't seen any dramatic change that would mark the boundary between the two plates. Okay. The Phase 3 science studies to date provide no evidence for a hydrothermal system or magma from which heat can be exploited within the central part of the resurgent dome of Long Valley caldera. The researchers continue. The observed temperatures in favor of the model in which there is favor a model in which there is no massive magma chamber in the upper 10 kilometers. Okay. All right. Now you could say, well, you got to go down deeper, man. Or you could say, well, that's the whole thing about all this is you can postulate and say, oh, well, it's down there somewhere, but you haven't been there, so why are you even saying that? And all the evidence points against it. It's like evolution. Oh, well, I've never seen one species evolve into another. I've seen beaks get longer and legs get longer. Who cares? But I've never seen a certain species change into a different species. Okay? Darwin's polar bear changing into a whale. Okay? Now, the evolutionists will say, oh, come on. You just haven't waited long enough. You have to wait millions of years. But it's like, seriously? You're going to throw that in there? Since when is that scientific? Oh, yeah, let's wait an unobservable amount of time for some maybe thing that maybe will happen if we believe enough. Okay. So, let's talk about plumes, okay? Hawaiian Islands. Now, the idea here is that the Hawaiian Island, the crust there is over top of this plume, this chamber of magma coming up to save us all. And that the crust it moves along, and so then you got this island chain. Okay, boom, it moves along, spits up the magma, makes a nice little island, and then move along, folks. It shifts over to the next one, spits up the magma, moves along, folks. I wonder if I can get my mouse to help guide us along here. Anyway, not that it'll matter. It's too small. Well, there's an easier way to explain island chains and all this. These are all on a fault line. It's like every time. Oh yeah, it's on a fault line. Oops, we didn't have to make up weird stuff about magic chambers of magma that no one's seen. It's just on a fault line. And so here, let's talk a few scientists here. Quote, it seems that we must abandon the convenient concept of fixed hotspots as reference points for past plate motions. In another science journal, Tectonophysics, an article had this to say about mantle plumes in '99. Quote, hypothesized mantle plumes do not appear responsible for most large igneous provinces. Instead, their very existence is questionable. The plumes, that is. No geological evidence of any kind, geochemical, petrological, thermal, topographic, requires mantle plumes. Close quote. In an uncommon challenge to an important aspect of the magma theory, this particular article emphasized a position of an outright abandonment of the theory. Quote, all the evidence that has been used so far to support the plume model, geochemical, petrological, thermal, topographic, is equivocal at best, if indeed not contrary. The plume idea is ad hoc, artificial, unnecessary, inadequate, and in some cases even self-defeating, and should be abandoned. All right. Moving on. A little more. You could talk about why these hotspots don't work. One of let's see here. One of the more damning pieces of evidence against mantle plume theory is the plume theory. The mantle plume theory is that regions of the crust above suspected mantle plumes don't actually appear to be hot, despite the fact that huge fountains of magma from the hot core should be rising directly beneath. In Hawaii, however, they found that the temperature below the sea floor to be much the very same as everywhere else. There's no anomalous heat flow. To make the false plume theory work, scientists concede that you have to just, quote, keep making up excuses and modifications to make plume theory work, close quote. Perhaps geologists finally see that what they thought they knew may be wrong after all. Quote, there are no samples of the inner earth being spat out of the Hawaiian volcanoes as we once thought. Everything is up for grabs. We'll have to acknowledge we know far less about the center of the earth than we thought we did, close quote. And, quote, most aren't convinced that mantle plumes should be dumped entirely. They're willing to admit that the geological community is standing on the brink of a radical shift in thinking that could completely change our ideas about the inner workings of the earth, close quote. Okay, so let's talk about the earth tide and quakes in regular cycles. So what causes lava and heat in the crust? The answer is the daily earth tide. You can see here the gravitational pull of the sun and the moon on the earth are doing this earth tide phenomena, and this is resulting in frictional melting. Quote, geophysicists have traditionally shied away from making such connections, close quote. So the Journal of Geophysical Research says between 1967 and 1983, 4 earthquake swarms, that's a series of little earthquakes, or big, just a series, occurred on Kilauea Volcano, Hawaii, with durations ranging from 68 to 156 hours. Plots of the number of events per hour show a remarkable modulation having diurnal and semidiurnal periodicities. Tidal influences appear to be the best explanation for the modulation of the activity. Wow. See, this is why these guys won't make this connection. Okay, if it's tidal, okay, if earthquakes are tidal rather than from magma pushing stuff around, then we don't need the magma. Okay. Again, quote, now some suspect that the earth is also breathing, compressing its crust and extending it once each year. This cycle is most evident in Japan, geophysicists told the meeting, where it may be responsible for that country's earthquake season. Elsewhere, it may lead some volcanoes to erupt almost solely between September and December. Close quote. So this idea of earthquake season, people hate that idea because it pins it down, and you can't pin down magma. You can't predict the magma. The magma. It's like this mysterious monster, right? That does whatever it wants. The god of the atheists is mysterious indeed. Forgive the constant puns. One more quote. The discovery of silent earthquakes is forcing scientists to reconsider various aspects of fault motion. One curious feature of these silent earthquakes is that they happen at regular intervals, so regular, in fact, that scientists are now predicting their occurrence successfully. This quote. Okay, so let's talk moonquakes. So a shaking from the breaking of Earth crust is an earthquake. So let's talk about the moonquake. Why does the moon have moonquakes? This is quite strange, no? If there's no magma on the moon because it's very small and it would have dried up by now, cooled down, then why the earthquakes? So moonquakes, as first observed by Apollo 12 seismometers in 1969, they occur at intervals of about 14 days. Apparently, they are triggered by the tidal forces exerted by the Earth. We admit moonquakes are due to tidal forces exerted by the Earth. Why can't we apply this to our earthquakes as well? The moon has little or no remaining internal heat. Quote, the moon, a body much smaller than the Earth, lost its internal heat relatively early in its history. As a result, it ceased to be an internally active planet about 1 billion years ago or so, they say. Close quote. There are no volcanoes or active lava flows on the moon, but there are moonquakes. Therefore, if the moon has no internal heated magma to cause quaking, why do they exist? From the book Melting the Earth, the author states that the moon is dead inside and that tidal forces are exerted by the Earth as the cause of the moonquakes. Okay. Yes, we talked about that. Okay, so a little more here. The To overview, we've got another diagram here of the volcano, the tuff cone, the hydrocrater, okay, and the diatreme with the water source and the fault line. Okay, the possibility of frictional melting during faulting has been suggested by several investigators. Okay, lava originates from frictional heat generated by movement in the crust. Crustal movement is attributed to the solar and lunar cycle diurnal effects, and the resulting melted rock moves along the paths of least resistance, including faults, subjecting the rising melted rock to further decompressional melting. Okay, here's a very cool diagram of earthquake swarm volcanic eruptions about how the quakes precede the lava. Okay, how can we tell when lava is going to happen? I was talking with somebody and they talked about how, oh, look, we discovered there's these gases that are released into the atmosphere that we can use that to predict when there's going to be an earthquake. And I say, okay, great. Where do the gases come from? And he says, well, I don't know. And I say, they come from the earthquakes. The earthquakes are releasing those gases. And so it's the earthquakes that are preceding the eruptions. The eruptions are not from magma. They are from, and again, I guess I didn't define this. Lava is what we call basically local melted rock. Magma is the term that infers this deep, massive ocean of melted substance in the middle of the earth and below the crust, generally. Anyway, so in this diagram, you can see the earthquake swarm is the black lines, and then the red line is the lava flow. It always happens after the earthquake, after. Okay, and there's a very small percentage uh, um, where it's during, but it's where the quaking is during the lava flow. But notice how there's never a case where the earthquake storm starts immediately after the volcanic eruptions. Okay. All right. So let's move on now. Okay, this is really funny. So, at 11:37 p.m. on the night of August 17, 1959, a large 7.5 earthquake rocked Yellowstone. The earthquake and the tremors following it caused hundreds of geysers to erupt. Okay, so earthquake happens, big earthquake, and then tons of geysers erupt. You following this? Okay. So quote, one of the greatest and longest lasting reminders of the quake was its effect on the geysers and hot springs. On the night of the tremors, and within the next few days, hundreds of geysers erupted, including many hot springs that had not been previously known as geysers. So, and then they go on to say, exactly what caused these eruptions is difficult to say. Okay, really? Is it so difficult to say? It was the dadgum earthquakes, man. Like, how long can they go on denying this? It's really sort of comical. But no, it has to be random magma. That's the only way we can have volcanism. So if you want to say earthquakes trigger this, no, of course not. Okay, let's move on. So let's talk a little more about subduction. Nobody has observed subduction. Okay, it's this is what it boils down to with science, and that something that Dean has taught me a few times that has really helped me with sorting out truth from error in science is who has seen it. Ask yourself, who has seen it happen? And if nobody's seen it, then we've got to be extremely skeptical of it in the realm of science. So in Origin of Mountains, it says, quote, there is no possibility of subduction. Subduction is taught as fact in almost every geology textbook in schools today. Okay, it's this idea of one plate bumping into the other and going down deep into the mantle, where it then is heated by the magma and then comes up through a volcano. However, researchers have shown that subduction hypothesis is not testable and therefore not proven. Without subduction, modern geology has no explanation for most of the acknowledged worldwide floods. In the colored diagram here, NOAA diagram, we see the melted and rising magma as shown as though it was generated when the subducted plate sinks into the hot mantle of the Earth. In actuality, the melted rock that shows up in volcanoes is generated by friction. The friction-induced lava, or extrusive lava, has become more accepted in some geological circles because researchers finally realized that there are earthquake-generating faults below all volcanoes. These faults move rock that is under great pressure, melting it where it can rise to the surface as lava. So, we're not saying that plates don't collide. We're saying that when they do collide, it's the friction that creates the lava, not the magical mantle magma. Okay, and one researcher says the real problem with subduction is that it can do everything. Plate collision may be invoked to explain uplift, making mountains, or subsidence, making deep trenches. It may make folds by compression, but make back arc basins by tension. The fact that the subduction hypothesis can account for both uplift and subduction, compression and tension, has too many degrees of freedom, and it cannot account for opposite effects and is not testable. Close quote. Okay, let's talk. So here's a diagram here. On the left, magma theory. Magma is coming in to save the day. On the right, no, it doesn't have to be that. It's just friction will do. Okay. So we've talked about that. Let's just move on here. Okay. Now, this is another cool thing. Let's take a look at this map here. This is a theoretical heat flow map. Okay. If there's magma down beneath the crust, that's hot, right? So now remember, where's the crust thickest? Well, it's the continents. It's 6 times thicker than the ocean crust. So the wherever we have ocean crust, the heat flow should be a lot more, but it's not. Okay, and so let's take a look at this. Let's take a look at the actual map. Oh my goodness! Look at the places where it's most heat. Oh, it's along the plate boundaries. Oh no! Oh no! That means that yeah, it's from the interaction of plates causing heat flow, not the general magma. Okay, so that's precious. Again, O.M. Phillips. The thermal history of the Earth is a problem of enormous difficulty. Mm-hmm. Okay, so here's again with the tomography. Okay, we've got all these different slices of what we can measure, and you'll notice it's not just hotter the deeper you go. Sometimes it's quite cool down there, and most of the extreme heat is in small pocket areas toward the crust, the very top. Okay, now if we had the magma, it would all be hot down low. Okay, and it's not always safe. Um, this is why Nicola Jones says, quote, the geological community is standing on the brink of a radical shift in thinking that could completely change our ideas about the inner workings of the Earth. As close quote. As far back as 1901, scientists recognized a problem with the origin of Earth's heat, recorded in the 1901 book Lessons in Physical Geography. Quote, the fact that while the temperature of the Earth crust increases downward, the temperature of the sea decreases in the same direction constitutes one of the most interesting problems of oceanic geography, close quote. Okay, moving on. So again, here's two diagrams. One is of the theoretical heat flow, one of the actual heat flow. Remember the crust, continental crust, 36 kilometer average thickness versus the oceanic crust, 6 kilometer average thickness. We should have the most heat coming off the crust. And again, the oceans are very small compared to all of this, so that you can't just say, oh, well, the ocean's in the way, that's why there's not more heat flow. Well, yeah, okay, when you look at the depths and the size of the crusts and the amount of magma they're saying is going on, that really doesn't, uh, you know, change things a whole lot. So yeah, well, look what's actually happening. There's more heat, much more heat, like almost double heat coming off the continent crust than on the ocean crust. Why? Well, this is because there's more rock, uh, thick rock here that is bending and breaking and generating frictional heats from as a result of these constant tidal forces. Now, what's below all this? Well, we've got a lot of water. We've got a lot of ice. We've got rock. Okay? But we've got a lot of water. We can't say that enough. That's why we've got the continental crust. It's a lot of rock. Okay? More than far below that. So what we're going to talk about later is that we say 99% of Earth's water is on the oceans. Well, we're going to flip that on its head and say 99% of Earth's water is under the crusts. Okay? So, let's move on here. Yeah. The, something else that we could address is the why the ocean crust looks so different than continent crust. So the ocean crust is this mafic rock, basalt, gabbro. The continental crust is this felsic rock, lightly colored like granite. Okay, the mafic ocean crust is darkly colored. And what it boils down to is that the continental crusts, remember how we talked about how the Earth used to be one big landmass called Pangaea? Well, when that breaks apart in the flood, you've got these hyperthermal conditions, and they're making the ocean crust. The ocean crust is a lot younger. Okay, and so as the plates spread apart, the biologically active hypertherm deep in the ocean uh, is at play here. Yeah, and note biologically active. So when the Earth was made, there wasn't biological activity in the beginning because the plant and animal life was not placed here until later. And by the way, later in mostly volume 2, it talks about how the only logical way that life got on Earth, plant, animal, and human life, is that it was put here. It was put here. It didn't evolve. It was put here by a higher intelligence. And what's so wrong with that? Why do scientists fall over dead at that idea? Because you don't got anything better. All you have is that it rained on a rock for a fairy tale amount of time, and then magically, poof, there was life. Like, is that easier to believe than that somebody came over here and put stuff here? Like, in this age of space exploration, you know, um, like, how are we so dense to think that there's not a human society that advanced and is able to, you know, influence things on a bigger cosmic scale and transport things? So yeah, life on Earth was brought here, and so so again, the oceanic crust. There was microbial activity that made the basalt, gabbro, etc., and um, we get a lot more into that when we're talking about flood stuff, but we're going to go on for now. Okay, so something to reemphasize here is that quartz, which is SiO2, is not from a melt, but glass SiO2 is. So we're working with silicon dioxide, but the one is from a melt, that's the glass, the other is not. Okay, if you melt quartz, yeah, you're going to get glass, but you can't go back from glass to quartz. Okay, because once it's melted, the crystal structure, it's all over. So can we sit here and say that the Earth was made from a big melt rock lava ball, and that it's mostly lava ball now still, when all of these rocks are SiO2 quartz? So it doesn't work. Okay, natural quartz does not form within magma conditions of high temperature, high pressure. If we do not comprehend how quartz, the most common mineral in the crust of Earth, forms, how can we explain the formation of the Earth? By melting temperature, uh, by the melting temperature, it's no longer natural quartz. There's a very specific window that you can have to form natural quartz. I'm going to move on because uh, obviously it's time to move on. And we got to get this done at some point. But we're all having fun, so... okay, so again, here's, you take a torch to a rock like this. It's going to get this globular melting going on here. And, that's very different. Quote, quartz cannot be grown from a melt because silicon dioxide quartz melts are so viscous that they form glasses rather than crystals when they are cooled. And again, quote, although the melt growth techniques provide rapid growth and are basically simpler and easier to control than growth from solution, there are certain materials for which melt techniques cannot be used. This is the case when the melt is so viscous that a glass would form, as happens with quartz. Okay, and this is a little picture of melted sand tubes, which are not crystalline structure. Again, the melt is not making the crystal structure common in the so much of our Earth. Okay, you've got these synthetic melt-grown emeralds. They have no water in their crystal matrix, whereas all natural emeralds do. Natural emeralds grow in the same manner as quartz, but higher temperature and pressure. And basically, you're going to find water in the molecular structure of all these rocks. And at some point, I think we talked about how there's a good amount of rock that is water, and all natural rocks have water in them. And this gets really strange when you're obsessed with the idea that all the rocks came from a melt. So pretty much the rock cycle has to go, because what's the heart of the rock cycle? It's magma. So, there's a whole chapter on that in I think it's chapter 6, after the magma chapter and before the hydroplanet chapter. So we see a precipitate isn't limited to chemical reaction. Look at your rock candy, right? So, and other situations where you're getting this crystal forming from a supersaturated solution as you decrease the temperature, etc. So a lot of times we think that, oh, to get a precipitate, I need to do a chemical reaction. Nope, because change in temperature and pressure can also trigger that. So this ties in because the technologists make rocks in water. Why do we think that all rocks came from magma? Okay. Um, let's see here. Yeah. So like the same process that we make this rock candy is basically the same process that natural salt formations are formed. And you get more into the creation of the earth as kind of like this water soup situation. And you've got all these precipitations happening as different energies are applied to it. And there's a bunch of experiments in that talk about and demonstrate these water-based creations of different rocks and minerals. Okay, James Hutton said that granite is also from a melt, but it has quartz crystals inside it. Yeah, so that can't be true because things that are from a melt can't have quartz crystals in them. Hutton says rocks don't dissolve in water, so they aren't from water. Okay, we talked about this. But just because you drop a rock in the water and it doesn't dissolve doesn't mean that it's not from the water, because right now we're not seeing the pressure and temperature that was existing at the time of the creation of the earth and the flood of the earth. Those were the two big hitters, the creation and the flood, of when we had these unique situations. So another thing is when you have a fossil, that's evidence of the flood right there. And something that we'll talk about is that, well, we talk more about it with the flood model, but that Earth's sands and clays and so forth, there's some of it from erosion, yeah, we get that. But the vast majority is actually little crystals um, from the flood. And when you start to learn about this, it 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 encompasses everything. It's everywhere. The flood is the most geologically obvious thing of all time. And when we take off our blinders, when we're willing to, you know, get down off of our atheist pedestal and admit what's going on, you know, everything changes and science can be reborn again. We can have interest in it. We can easily explain it. We can get our kids involved. We can make extreme advancements in our understanding and our technology. Okay. Today, scientists deny that quartz cannot come from a melt, despite demonstrations of engineers. So this is the craziest thing. The engineers are often the ones, the technologists, they're actually leading us to more good science than the scientists, because the scientists these days are so theoretical. But over and over, these engineers are like, no, we can't make quartz from a melt. Sorry. Remember we talked about the World War II, they need all those quartz watches and all this. You have to do it from a solution, a water solution. Okay? All right, moving on here. So, yeah, water is how God created the earth. Quartz are 90% of all rocks, and they came from water. A hypertherm, again, this is water, pressure, and heat. And so let's talk about these cool universe laws of water. Number one, the law of primordial matter, that water is the primordial matter in the universe. And number two, the law of hydrogenesis, that all other matter originated from water. And number three, the law of hydroformation, that all natural crystalline minerals formed in water. And number four, the law of hydrobiogenesis, that all organisms are born in water. All right. I gotta pause for 2 seconds. Write down something I just had an insight of that I'm very excited about. Let's see if I can remember how to pause. All right, back in action here. So we're moving right along, and I don't think the rest of this is going to take as long as the first part because we just kind of grace on some of this last stuff. But yeah, we'll be here a little longer, but that's okay because we're having fun. We're party animals. So crystalline structures are made with water, not a melt. Okay, here's some hyperthermal quartz growth. He's got this high pressure reactor. He sets the pressure such that it would simulate the flood pressures, which is the 30,000 meters, about 5 miles deep, and the about, what was it? Yeah, so forth and so forth. 350 to 400 degrees Celsius. So you can compare the growth here, and it's pretty amazing what's going on here. This is a man-made quartz crystal grown for technological purposes. The clear strip seen in the bottom photo is the quartz seed, while the blue material is the grown quartz. The addition of the element chromium is responsible for the blue. Temperatures of Earth's interior are unknown. So there's all this hype about how in the middle of the Earth it's hot. I guess from the idea of the hot uranium being down there and all this, but again, we already talked about uranium's ore is not even hot, and there's these other ideas. You know, if you're gonna have your magma, it's got to be hot, right? And so they say, okay, well, in the beginning, the Earth was made very hot. Okay, it was all on fire everywhere, and so. But let's see if we really know what we're talking about when we're talking about how hot it is down there. When quote, direct measurement of temperatures in the well compels revision of ideas about the distribution and flow of heat in the Earth's interior, close quote. Quote, how do we know the temperature? The answer is that we really don't, at least not with great certainty or precision. The center of the Earth lies about 6,400 kilometers or 4,000 miles beneath our feet. But the deepest that's ever been possible to drill to make direct measurements of temperature or other physical quantities is just about 10 kilometers or 6 miles. So, yeah, talk about we're basically like need to go 1,000 times deeper to figure out what's going on. As a result, scientists must infer the temperature in the Earth's deep interior indirectly. So this temperature stuff, it's an indirect inference based on all this bogus stuff that they're, you know, basing their inferring on. Quote, like the crust, the upper mantle portion of the lithosphere beneath the plateau should thicken as the continental plates collide, which should make the lithospheric mantle colder and stronger. Yet the upper mantle in this region, in contrast, appears only to be weak, not only to be weak, but is also relatively hot, as evidenced by the uppermost Tibetan mantle in the presence of active volcanism throughout much of the plateau. This is hardly what we would expect from thickened cold lithosphere. This unexpected heat, common to many mountain-building regions, has been termed the orogeny paradox. Okay, so yeah. So basically, they're seeing the opposite of what they're touting, as far as the top being hot and the bottom being cold. So geologists admit they have very little information about the Earth's interior. Quote, at present, all geologists can do is draw certain conclusions from the limited information they have about temperature. Simply said, they do not know the temperature of the mantle or core of the Earth. Quote, they combined the, here's an example of them inferring. So they combined, quote, they combined the temperature of lava that originates in the mantle and emerges from volcanoes, laboratory data on the temperatures at which rocks and iron begin to melt, and information from seismology to infer the geotherm from the surface to the very center of the Earth, where they believe the temperature rises to between 4,500 degrees Celsius, close quote. So again, they're basing this on where iron melts, like, and all this weird stuff. So yeah, all of geology is built on this hot Earth, but they don't even know if we have a hot Earth. Okay, so the deeper the colder, because heat is local. You wear a jacket when you go in a cave because the cave is colder as you're going deeper. Okay, you're getting away from the sun and it's getting colder. It's not getting hotter because you're approaching closer to the magma. The only time when you're going to have a deep underground hot situation is when you're near a fault line. Okay. Drillers say the deeper you go, the more cold and wet it is. Again, we talked about the 1901 lessons in physical geography. Quote, the fact that while the temperature of the Earth crust increases downward, the temperature of the sea decreases in the same direction. This constitutes one of the most interesting problems of oceanic geography. Close quote. And, quote, the model that emerges is one of the internal temperature of the Earth, in which the internal temperature of the Earth is governed largely by the generation of heat in the Earth's crust and possibly a little below it. And, quote, the fire is not concentrated deep in the heart of the Earth, but is an encircling sheet near the surface itself. And, quote, despite the availability of data for the upper third of the crust, models to predict temperatures for greater depths still contain uncertainties. So another important point here is the lack of vertical plate movement. I think I have a picture here, but we'll talk for a minute first. So they're saying there's all this uplift as to why we have seashells on mountaintops and mountain ridges. We're talking tall mountains, we're talking Everest, etc. Okay, why are there marine fossils on mountaintops? Okay, well, we're going to say the water was up there and the hypertherm conditions of not just water, but enough water on top of that mountain to make a pressurized situation where silica was driven into the molecular structure of that bone, that wood, etc. And, that it made fossils. And so we have maps showing horizontal plate movement, but not vertical. Okay? Mount Everest has not gone up or down like at all in all the time we've been able to measure. And so this idea that, the mountains are slowly coming up, it's not happening, are slowly going down. Here's a question. Where's the submerged continents? If things are slowly going down and up, okay, we've got some high continents and high mountains. Where's the submerged continents? They don't exist because all we have is Pangaea, the created Earth, Pangaea, and then we've got ocean crust. Okay. So let's talk about, also the subduction slow downward movement is not happening. Okay. We've got short period of time micro uplift where it's small amount of rising or lifting of hills or, well, I won't say small, just lifting of hills or mountains in short period of time above the surrounding landscape. Okay, this is from, again, catastrophic events. Okay, the macro uplift theory, this is the theoretical one. This is where you've got the lifting of large land masses or continents above the surrounding landscape over long periods of geologic time. Okay, this is another thing that Dean brings up against the common ideas of plate tectonics, is that they're saying, science says that, it took these plates millions of years to move, and they're being moved by the convection currents, and they're doing all this, those are some of the main problems there. The magma explains why it's happening according to them, but we're going to turn around and say there's no magma, so you don't know why they're moving, and guess what? They moved a lot faster than you think because it was from a catastrophic event in the first place. And any remaining movement is related to tidal forces. Okay, so here's again your horizontal plate movement maps, but no vertical. You're not going to find it. Vertical plate movement map, nope, doesn't exist. And submerged continents, nope, doesn't exist. Okay, quote, without uplift and erosion, there would be no Grand Canyon. Okay, they're trying to, so when it comes to Grand Canyon, The idea with Grand Canyon is that there was a major earthquake that revealed the canyon, and there's major flooding that carved out as another possibility. But basically, um, mainly we've got the major earthquakes just opening up the earth. So they're going to talk about uplift and erosion here. Um, so without uplift and erosion, there would be no Grand Canyon. Up until the close of the Cretaceous period, 60 million years ago, the area that is now northern Arizona was for most of its existence a low flat-lying plain. Sometimes it was slightly above sea level, receiving deposits from rivers and wind-blown sand. Other times the area was below sea level. It was not until the whole area was uplifted over 10,000 feet and then eroded and sculpted to its present form that the Grand Canyon we know today came to be. So this is a pretty wacky situation here that they're describing. Let's go on. So again, Mount Everest, we've got GPS satellite, okay, altimetry measurement. This is not going up and down, folks. The horizontal position of Everest seems to be moving steadily and slightly northeast between 6 centimeters, 2.4 inches a year. But there's no measurable change in the height ever observed on Everest, okay, from Bradford Washburn head researcher. So this whole uplift idea is just not cutting the mustard. Okay, so this next part is shorter. It's on the hydroplanet stuff, but I do want to include it because it's really hard when we say magma doesn't exist if we don't come right back and say, but this is what does exist. So I'm going to try and fill in some gaps with this. I'm going to try not talk myself to death. Okay, so an overview. Water earth evidences. There's the water in vacuum versus in space, the water's spherical behavior, the water precipitating crystals, the water blocking satellite, the water in the planets, moon, sun, and comets. We're going to talk about how there's tons of water in them, even in all these things. Water in rocks and in hydros, water, quartz versus glass melt. We've talked about some of that, so we'll be able to go through some of this. Okay, water on planets. Look at this Martian soil map here. Look how much water is in Martian soil. Okay, this map of the surface of Mars illustrates the abundance of water in the topmost meter of Martian soil. The key represents the percentage of water on the soil by weight. The data for this map came from the neutron spectrometer on board the Mars Odyssey spacecraft in 2003. The blue areas have enormous amounts of water. Okay, now let's take a look at Saturn's rings. They are made primarily of water ice, says NASA. Okay. Yeah. So they're made primarily of water ice from hydro fountains found on Saturn's moons, which will be covered later. Okay. These moons around Saturn, they explode, sending out all this water, and then that is frozen and joins the party of the rings of Saturn. Okay, so water in stars and nebulas. How about the sun? Okay, so one of the last places you'd think there would be water is on the sun, but there it was. Researchers confirmed this discovery by comparing water emission spectra from hot water in the lab to those observed on the sun. Let's look at the water in the Orion Nebula. When researchers looked for water inside the Orion Nebula, one of them declared it must be raining in Orion. This was due to the strong water line found with the maser. The water signal was stronger than elemental hydrogen, the supposed most abundant substance in the universe. And something that, you'll learn about with is that water, the compound of water is more abundant than just the element hydrogen floating around. Okay. As a gas or even liquid, we have water in stars and nebulas. Water, ice, and liquid exist in hot conditions when temperature is high. Okay, in this different pressure situation, and of course we've got the gas form, etc. And then, who knows what's down in the deep. Let's talk about water on moons and asteroids. Okay, this is Ceres. It's got this. This is a near-Earth asteroid that is 590 miles in diameter, traveling around the sun. Scientists now estimate Ceres has at least 77 miles, or 124 kilometers, of mantle of ice that represents 1/4 of its mass. Ceres is truly a hydroid by definition. Okay, the Tethys hydrosphere. This moon is known to have a density very close to that of water, indicating it is likely composed mainly of water ice. Okay. Perhaps, let's see. Yes, perhaps the only thing to surpass the beauty of Saturn and her moons is the understanding that celestial bodies formed from the most abundant substance in the universe, which is water. They did not form from melted rock. All right, let's look over here on the right. This montage shows 4 major icy moons of Saturn. All of these bodies are made largely of ice. Okay. As we look further from the sun, there is an abundance of bodies made largely of ice. As we extend our reaches into the depths of space, one substance consistently shows up everywhere we look, and that is water. Water moons. Okay. 3 hydrospheres, also known as hydromoons, orbit Jupiter. These hydromoons each contain large amounts of water. These, from drawings adapted from NASA, each sphere is shown representative of how much water each hydrosphere is thought to contain. The amount of water researchers discovered in the moons is massive. The percentage of water they hold is even higher than is proposed for the hydroplanet Earth model in this chapter. So how much dang water is there in the Earth? There's a lot more than we think. And we're being, in the he's giving conservative estimates on how much water is in the Earth. Yeah. So let's look at the Europa hydrosphere. Okay. Planetary scientists conclude that Europa, smaller than Earth's moon, holds an ocean 150 kilometers, 93 miles deep. Okay? 93-mile deep ocean on this thing smaller than our moon. The Earth's oceans are average only about 2.5 miles. The enlarged section of Europa's crust shows an icy surface that has been broken and fractured by the tidal action of the moon's nearby planet Jupiter. Brown areas are sediments blown onto the surface by steam and water carried from below the surface. They're an important part of this hydro fountain concept. Okay? What is a hydro fountain? I don't know if I defined that in this lecture. It's basically a water volcano. Okay? It's where water is bursting to the surface. And of course, you've got mud volcanoes. Those are really common too. And what do you need to make mud? Well, rocks and water. And a lot of people don't realize that. I don't think we're going to talk about this later. Mount St. Helens eruption, 1980. It didn't have any lava that came out of it. So, yeah, it's the most common thing, that we're getting out of these is water. Gas water, liquid water. Okay, depending on the situation. All right, let's go on. Okay, this is exciting stuff. This is when you actually look in space and you find these cool comparatives of how, it really brings home the reality of water-based celestial objects, and then we turn around and see why not allow ourselves to consider the possibility for our own Earth like this. Okay, the Callisto hydromoon. So, yeah. Let's see here. In this diagram, the various images of the hydromoon Callisto, the second largest of Jupiter's moons. Plate 1 is a NASA illustration showing an icy crust, subocean, and an ice rock layer. Plate 2 compares the surfaces of Europa, Ganymede, and Callisto, showing a dark material layer that is easily accounted for in the hydroplanet model. Plate 3 shows icy spires, landforms difficult to explain without a water origin. Okay, and then over here on the right, we've got the abundance of water on the Ganymede hydrosphere shown. This is imaged in the near infrared. These false color illustrations show significant water, which are areas of both green and blue. Okay, on Ganymede there. Okay, take a look at this. Enceladus hydrosphere, hydrofountain in process. Okay, this is a real-time eruption seen by the Cassini spacecraft. Large canyons from previous ruptures in plate 3. Okay, this contributes to Saturn's water rings, as we mentioned. Plate 4 is the hottest near-surface cracks, or the faults. So you see that crack running right through there? Well, that's where it's the hottest. It's just like we were talking about with the Earth, how the real heat flow map shows that it's by the faults, not just the oceanic thin crust in general, that we get the highest temperatures. So, and then the density is about 1.5. That's just more than water, which is the density of 1. Okay, so this thing is like almost pure water floating around in space, and boom, this mega water fountain explodes, from these tidal pressures and whatnot. Okay, so the surface is where you have the most hyperthermal exposure and you get the most formation. This is the Thunder Egg formation. As you can see, you get closer to the surface, you get the most of the mineral formation. The analogy here is that the Earth is basically a geode. Okay? Isn't that an amazing idea? Now, do geodes form in fire or water? There was a funny... I didn't... as I was doing some of this research, I went to a kids' science fair, and they were talking about how geodes were made, and they talked about how there's all this water in the geodes and all this. And I say, so how'd the water get in there? And the kid's like, well, of course it's a kid, so you don't expect him to know. But anyway, and they're telling me, I say, okay, well, how is the geode made? They say, oh, well, take a look here. It's the lava. All this lava happens, and, boom, you've got a geode. And anyway, so this idea that you can have the groundwater leaching over slow, long time is pretty whack, because you don't reach the pressure needed you can't just leach it in. So if you're going to actually, get the silica into the molecular structure there, you're going to need the water, you're going to need the pressure, you're going to need the heat. Okay. That's the whole problem with, they say the dinosaurs, they're getting away from the theory of dinosaurs dying by the comet hitting the Earth and all this, but they are, so they're talking about flooding, but they're still not quite ready to admit catastrophic flooding. I mean, in a lot of places they do, okay, catastrophic flooding. But a lot of them are still saying, well, they died, and then there was this waters that came up, and they got buried in the mud, and then a long time later, they turned into fossils. Okay, whoa, pause the tape. A long time later, they turned into fossils. What are you talking about, a long time later, they turned into fossils? Because a long time later, they decompose, okay? And if they're dead and laying around, they get scavenged. So there's all these problems of why fossils should have never happened. Fossils should have never happened. According to this common theory of uniform theory, that everything's happening the same way over and over throughout time, and that there's no real catastrophic things. What we're getting at here is that the flood of Noah made all the fossils. Okay, there's very, very rare exceptions at places where you sort of replicate flood environment, like the bottom of the ocean, some hydrothermal vents down there. Okay, now you're getting some weak rock formations, geyserite around the waters, hot waters coming out of the geysers, but these are very different than the fossil rocks. And basically, anywhere you see a fossil, there was the flood. So if you're wondering if the flood was worldwide, well, now you know, because anywhere you see a fossil, there was the flood. And the worldwide baptism of the earth, man, that's a big deal. We talk about the earth being alive. We talk about the earth going through, that was his baptism. It's Christian baptism right there. The earth, and it's going to die and be resurrected. It's going to get the baptism of fire and the Holy Ghost, right? We talk about how Jesus is coming back with the fire. Well, guess what? That's going to be the baptism of fire for that. And it's going to be, it's symbolic and literal, all this stuff. Okay, that's a big problem these days is when people want to take all the scriptures and say they're all symbolic and it has nothing to do with science and all this, you know. Of course, we're not going to like nitpick and twist scriptures to make pseudoscience like the sun revolving around the earth from some supposed scriptures. That's not what I'm talking about. We're talking about how, generally speaking, there are scientific truths presented in the Bible about the creation, about the flood, etc. Okay, a lot of things, really. All right, so you open the geode, the water comes out, and we don't have a slow leaching thing. Okay, this is the first man-made geode right here. UM's got a lot of discoveries. This is why Dean is not just a philosopher; he is a scientist. He likes to point out, we've got people like Einstein. They're just sitting around in their head doing a bunch of math, but you actually need to put your theories to work and test them in a lab. Okay, so we've got these quartz crystals growing and so forth. Let's see here. Another important thing about geodes is that they're found only on or near the surface of the earth. Okay, like we talked about with fossils, only near the surface. Okay, if geological timescale was true, geodes would have formed during many different times and would have been found in many different layers of the crust. Since they are not, the environment in which they formed must be very different from the one alleged by modern science. Okay, geodes aren't just out there forming. Okay, they're not in all the layers of the earth. These were a recent phenomena from the flood. Here we have on the far right Amalthea, the fifth of Jupiter's satellites to be discovered, seen from a flyby in 1999. Amalthea's density has been calculated to be less than that of water, indicating a hollow core geode-like structure. Okay, you got a density less than water, means you got a lot of hollow stuff going on too. And then we'll talk about, see that massive supposed impact crater on the side of that? Okay, we're going to talk a little about how those are not impact craters. They are, in fact, hydro craters. Okay, they are remnants from an implosion where water was ejected. So, yeah, if you had a big old impact like that, it would have obliterated that asteroid. So that was not an impact. And a lot of what you're seeing on the Earth is not impact. And a lot of the meteorites you're finding from space are not really from space. They are blown out of these hydro fountains. Okay? I don't mean to be, crashing everybody's party, but it's got to happen sooner or later. And you'll find a lot more on that. And we got to have some fun with this. So again, we brought up water in rocks. Look at this. Look at all that water in these rocks. Opal contains up to 30% water. Okay, one of the wettest rocks on the Earth, from mines in Australia. But these can be grown synthetically. Okay, and when you grow the opal in a lab, guess what you need? You need a lot of water. Okay. When another interesting thing is that when you heat a rock, it'll weigh less afterward due to the inside water evaporating. Okay, and there's some more going on there that we'll address later. But now, why can't you see the water in the rocks? Okay, well, it's like a germ, but on the microscopic level. Okay, so we're not going back to Stone Age here. We're not going pre-industrial, Enlightenment and saying, oh, I can't see it, so it doesn't exist. Okay, watch out for that. Rock formulas typically contain H2O. Okay, Now let's talk about on the right. This glassy looking rock is obsidian, and the amount of water shown in the two beakers is the amount of water contained in the obsidian rock shown. Okay. So we're talking 18 grams of water in a 617 gram rock. Okay. This rock actually has up to this much, about 3% of by weight water in it. Why do we not see the water? Okay, the same reason we don't see germs. The water is in the microstructure of the minerals, too small for the naked eye. However, we can heat the rocks slowly, then weigh them after to see how they've cooled, to see how much weight in water was lost. Okay, why weren't we taught this in school? For the simple reason that the unseen water in rocks has always been a mystery to geology, and in general, it did not fit well with the magma earth theory. Okay, many geologists don't even know that these exist. These are called anhydrous. This is water trapped in rocks. Okay, water and gases. So this shows that the water was made in the rocks were made in a water environment. Now on the left bottom corner here, you've got the ice cube and hydro. Okay, you put the ice in your freezer. If you got a really cold freezer, it can freeze fast enough to where it's going to trap a bubble of gas, air, or liquid water inside. So it's going to encase around there. And now, if you were to take that ice cube, you'd say, what environment did this ice cube form in? Was it lava or water? Okay, well, it was in water. And part of the evidence is there's some dadgum water right inside that rock. And so this is a closed system. Okay, so gas condensing to liquid would implode it. Okay, but that's not happened. It's not imploded. It's not gas condensing to liquid. So they say, oh, well, gas must have been trapped in the rock in its formation, and then it condensed into liquid. Yeah, well, that would make a negative pressure to implode it. So I think it was water trapped inside it while it was forming, and that gives a pretty big giveaway of how a water-based formation. And why does this matter? Because you zoom out, you get the big picture, and it's what's going on in the whole world. Okay, with the world formation, with all the, with and a lot of water beneath the Earth surface, and a lot of all these rocks being made in a watery environment. Okay, so yeah. This wouldn't survive an ice age, by the way, because solid water expands and it would explode the enclosed system. So that's going to be another party that we're going to have to crash. We'll talk about that another day. Most geologists, yeah, they don't exist and they can't explain them. Let's see this stuff. Okay. I've held some of these. You can move them around. You see the bubble move inside the rock. It's really cool. And yeah. So inclusions in anhydrous contain more than water. They include remains of microbial activity in the form of gases. Carbon dioxide and methane are common gases found in inclusions formed on or near the surface of Earth's crust. Conversely, recycled or uplifted and subducted igneous rocks theorized to have formed deep in the mantle, essentially zero methane is found. This is direct evidence that the mantle materials of various sorts lacking methane were never subducted or uplifted, but were created in a lifeless, or Earth's early creation, hydrothermal environment. So, yeah, when lifeless, as in not the flood time when there was all the life on Earth, but in the initial creation of the Earth before life was put here, that's where you've got the more of the gray granite and all this, because that was before the microbes and the life and all this. Okay, so yeah, let's move on. Okay, fossils similar to geodes formed in a flood hypertherm. This is dinosaur fossil agate. Fossilized dinosaur bones were changed into agate just as other geodes and agates were in the universal flood hypertherm, only on or near the surface. Okay, again, all your stuff about the bones of dinosaurs getting more complex as you go near the surface and more simple towards the bottom because of evolution. That's not a thing. Okay, that's a fairy tale. It's not observed in nature. And If there's any sorting at all, it's very elementary water-based sorting, but there's really not much, if any, sorting. And so what we've got here is these fossilized bone specimens are filled with agate comprised of the same material as geodes, as they are both formed in a hypertherm environment at the same time. Okay, there's a big one, at the same time. This was an event in history. This was not something that's happening all the time, and it's not happening right now. There's no in-process fossils. Open cavities, whether inside bones or pockets in the sediment, were filled with siliceous fluid that crystallized into agate rocks during the flood hypertherm. Okay. So here we've got water-made continent granite. Okay, the steam escapes through the holes. Okay, this unique. I'll start on the right. This unique granite outcrop is located in Sonora, Mexico, near the Gulf of California. Most granite deposits do not exhibit holes like these. Researchers have attempted to form granite through experimentation of many pressure, temperature environments, all without water. They had no success. Eventually, they discovered the water content was the most critical factor to stimulate nature in growing granite. And without granite, there would be no continents. Okay? So the continents were made in the water solution. Bombshell. Okay, on the left, volcanic rocks like these are lightweight because of the holes caused by escaping steam. Okay, and what is this steam? Well, it's a gas water. These rocks are typical of volcanic rocks. They are amorphous or glass-like and exhibit characteristic vesicles or holes caused by escaping steam. Researchers have long known that all volcanic rocks contain some water bound up in the minerals or the rock. This can be easily demonstrated by weighing the rock, slowly heating it, and letting the rock cool, then weighing the rock again. The heat causes the water to expand and escape through microfractures in the rocks. Yep. So even in the volcanic rocks. And a lot of what we think is volcanic rock is not. And we'll get into that later. So this is geyserite. It's a low pressure situation. Okay. So you've got the hot water and it's making some kind of a soft rock here, but it's not the quartz rock, which needs the high pressure. So we're talking high pressure. The way we're getting that is this water is so deep. Like if you go swimming, the deeper you go, the more pressure you feel, right? Well, if you have this 5-mile deep water all around the world, you got some serious pressure, okay? And serious pressure and heat, you got and mineralizer, okay? You've got the magic recipe right there to make fossils and amazing rocks. And you know, we're starting to understand how God's doing this stuff, and it's so calculated and so awesome and so powerful for evidence for the Bible. And this research is really important because it affirms the correct interpretation of the Bible too. There's a way to interpret the Bible where you write all this off and it's not really important, and it's theoretical and all this. Okay, so let's try to so the basic point here is that the geysers and hot springs do not produce quartz rocks and minerals because they are not under pressure. Okay. All right. So again, here's something cool: is that we actually have an equatorial bulge. Quote: in fact, more than 400 kilometers inside the Earth, there may be enough water to replace the surface oceans more than 10 times. Okay, and again, it's actually possibly a lot more than that, than just 10, but they're starting to admit this stuff, and they've got to start somewhere, right? Quote: the viscosity of the liquid outer core is comparable to that of water, close quote. So, yeah, it's comparable to water, huh? Okay. Why isn't it, they're never going to admit, right? So, this equatorial bulge is a big evidence that we've got a lot of water in there to allow for this bulge, too. It's not a perfect sphere. There's this 27-mile equatorial bulge, okay, evidencing a liquid interior. Okay, and the question is, what liquid? Okay. Well, we'd say water. Let's move on. So again, the oceans are what we'd say is 1% of all of Earth's water, and below that, below, not just below the surface of the ocean, but below the ocean crust, below the ocean floor, okay? And there's more on the formation of the ocean crust that is really interesting that you can look into in UM. Okay, so continents do float. Underwater is connected. Scientists admit that continents float. They just say it's on magma. Okay, take a look at this. An earthquake in Alaska changes the height of wells in Texas 3,000 miles away. So there's a little map to kind of relay that, drive that home. So this is a piece of pumice representing a floating continent. Adding ice to the water causes the water level and the pumice to rise together. Global sea level rises the same way when ice slides off land into the ocean. So don't worry about getting buried by water, by glaciers, because we'd all rise together. So, and I don't know if I put it in here. Probably didn't, but there's some more evidences of that in the text. Some locals measuring their in a, I'm trying to remember where it was, up north, very high up north, and yeah. I gotta move on. Lots of water exiting volcanoes. So we talked a little about this. I'm glad I have some pictures though for you. So hydrovolcanoes are another evidence for the vast amount of water that's in our planet. And again, there was some snow on top of Mount St. Helens. Excuse me, I said 1980 earlier. We're looking at 1982. So there's snow on top, and they said, oh, that's where the water came from for all the mud flow. But they've done the measurements, and that doesn't even begin to account for all the water that came out of that volcano, and that is evident in the mud flows. So anyway, where did all the water come from for these mud flows? Yep, it came out of the volcano. Um, there, yeah, and we mentioned no lava coming out of Mount St. Helens. Mount St. Helens was a really big eruption in our time that helps us see a lot of things. For example, the trees that were buried by the mud flows and all that, the animals, they're not turning into fossils. So this idea that, oh, the dinosaurs died by volcanoes and the mud from the volcanoes buries them and they get fossilized and all this. So that doesn't happen, okay? They're just going to break down like any other situation. The reason that we have the fossils is because there was this magical divine recipe from God, okay? We don't have to say magical, but we're going to say amazing recipe from God that he wanted those fossils to be made. He wanted that testament to be made, okay? And it was a unique thing. And it doesn't just happen from random volcano mud, okay? So let's move on here. The most numerous type of crater in the solar system is the hydrocrater. So again, a lot of these craters that we think are impact, including the famous Arizona meteor crater, are in fact not impact. They are implosions from the remainders of a explosion, a water volcano area diatreme situation. So here's an interesting thing. 8 hydrocraters on a fault line. Yeah, they're on a fault line, huh? Okay, that's always a smoking gun. So these 8 yellow dots represent 8 mysterious explosions that occurred along a 700-kilometer long fault line stretching across 4 states in the U.S. Although impactologists have tried to link these craters to impact, there are still 2 on the Earth Impact Database. John Lukzag calculates that the chance of alignment of impact structures like these is less than 1 in a billion. Because the craters are not all the same age and are related in other regional tectonic features, Lukzag concludes that they are not of impact origin but of volcanic origin. An important corollary to this conclusion is to show that shatter cones and shocked quartz are found at some of the craters, which is also of volcanic origin, and thus they cannot be used as impact criterion. So when we talk about volcanic origin, just remember that volcanoes don't have to be uh, lava based. Even they can, you know, but what we're looking at here is that these are craters that were not from impact. Um, and here on the right, hydrocrater survey. Okay, a bunch of different hydrocraters as well. We'll talk. I think I have a couple more things on that, but here's some disasters on water-based volcanology. Okay, I don't know if that's Chai Chi or what. Earthquake, 1999, in Taiwan. Okay, it produced hydro rock fountains, so rocks were getting thrown out of it too, strong enough to hurl huge boulders into the air. Investigators reported that when the dust settled, deep holes pitted the ground, as though columns of rock had been blasted out. Deep holes like these are remnants of hydro rock fountains, and though rare, can be found in the landscape if one looks with the paradigm of the hydroplanet model. Erosion in time has erased most of them, but some have been preserved for us to see. Okay, this is without volcanic eruption, so there's not like magma, there's not lava even. The ground seemed to explode as huge boulders were flung into the air. Okay, crustal water triggering a dangerous hydrocrater. Okay, near Kobe there is no active volcano, and heat flow studies revealed no significant lateral changes in temperature before the earthquake. Therefore, we suggest that the anomaly at the Kobe hypo crater is not related to a magma reservoir, but rather to the presence of fluids in the crust. Boom. Geologists have a code word, by the way, for water. When they don't want to admit that water is going on, they call it fluids. It's always fluids instead of water. The Earth has a hydro-plumbing system that is influenced by earthquakes that occur throughout the crust. Yellowstone Park in Wyoming is a good example of how frequent earthquakes heat subterranean and produce uh, geysers. There are many examples like this worldwide. Okay, so this is kind of fun. The moon. So why does the dark side of the moon look so different than the near side of the moon, huh? Well, um, so the far side and the near side. Um, Here's how it works. All these little things you're seeing here are not, uh, most of them are not impact craters. Okay? And again, the scientists are dying and falling over uh, into their graves. Um, so, what's going on here is a bunch of hydro craters, okay? The hydro moon. Because remember, all these things in space are water based and water made. And we're not seeing water on the surface of the moon because there's no atmosphere, and it gets licked up when it gets to the surface pretty quick. And let's talk about the near side, far side. So the near side is where there's more gravitational pull of the Earth felt, and so it's pulling that water toward the near side. And we're having more water eruptions on the near side. That's why there's so many more pockets on the near side than the far side. Okay? Yeah. So the moon does, of course, have some impact craters, but most are hydrocraters. Okay? For example, where are the impact ejecta blankets and rays on these fresh craters? Well, they don't exist because these craters are hydrocraters. Okay? So this is where it matters. So, quote, the history of lunar science is largely the history of the debate of the origin of craters, close quote. So if they can figure out where these craters came from, are they impact, are they, imploded volcanology, then they can decide how the moon was basically like everything about the moon. So, yeah. What's fun with science is when you can show how, when you discover true science, all true science bears witness of God. And that's what makes it fun. I mentioned this at the beginning. of it, of the lecture as well. And that's how you connect it to how it's meaningful in your life, and it really opens it up to a new level of excitement and interest. Okay, so yeah, think about your pancakes. You know how there's those little uh, what looks like craters all over your pancake when you're making it? So that's when the batter is turning to steam. Okay, uh, and the liquid batter turns to steam and comes out. Now, was there a bunch of little impacts on your pancake? No, obviously not. Okay, so are these impact craters on your pancake? No, those are, um, we could call them hydro fountain craters on your pancake. Okay, so water gas coming out and leaving little craters behind. So that's how that goes. Um, yeah. So, and again, the the scientists know that there's no magma in the moon. They're not even trying to say there's magma in the moon, but they're kind of scratching their heads about why there's earthquakes on the moon, because, or moonquakes, we could call them, because, there's not magma pushing plates around, you know, getting things all riled up. Um, yeah. So they've got to admit some tidal forces involved there, but tidal forces relating to some earth, you know, earthquakes? No way, no way, no way, never. All right, so here's another cool map with some diatremes and other stuff going on with some heat from friction along a fault. Okay, a large hydrocrater with central peaks, water sources, different hydrocraters. Okay, we've got some bullseye hydrocraters, which is multiple supposed impacts in the exact same spot, and sometimes you get a double, or even more than a double bullseye. And the idea here is, well, yeah, if it's on a fault line, it's explainable of how it's going to happen in the same place a couple times. Um, but we're not, the gods playing darts, right? Throwing little rocks at trying to get the bullseye multiple times in a row, I guess, it's so unlikely, right? Is why we have to say it's the gods throwing darts, because it's obvious that, and I'll show some more pictures that I think I might have some coming up, more of those bullseyes. So let me see if there's some here I want to finish off first. Quote, across the moon, both in Highlands and in Maria, we find strange landforms that do not conform to our notions or understanding of the lunar process. Yep, pretty strange, because y'all don't understand the lunar process. All right. The impact, boulder mystery, and answer. Why would half of the similar impact craters have boulders and the other half not? Okay. So we find it significant that over half of the mapped craters are boulderless. Okay. So why do only half of them have boulders? Okay. Yeah, it's because half of them are not from impact, right? Okay. Two images of the surface of the asteroid Eros. The overlapping image on the left is a close-up. Researchers found it significant that similar-sized craters in the same vicinity contain completely different populations of boulders. How does impact theory account for this? Hydrocraters provide an easy answer for this phenomena. Multiple eruptions from different sublevels, each producing different populations of boulders in different craters. Um, so, yeah, no lava flow on the moon. Okay. For the most part, the Maria appear to form a smooth, nondescript surface, and discrete flows are not visible. Lunar basalt formed in place hyperthermally. Okay. Um, the real lava flows on Earth. Okay, that's what it looks like. But they're saying that they're trying to give a similar history for a lot of this, this lava explanations to the moon as we see on the Earth, but yeah, it's not there. So why are there so-called lava flows on the moon that look nothing like the lava flows on the Earth? Geoscientists have been unable to answer this question with any degree of certainty. Note how formerly molten liquid rock on the Earth forms flows and ripples. No landforms of this sort have ever been seen on the lunar surface. Could the moon have had a watery origin? If so, this would answer enigmatic lunar mysteries that have persisted for more than a century. Okay. Yep. Watery origin. All right. So, yeah, there's a better picture of the dark side or far side versus the visible near side. Again, near side's got way more stuff going on. Okay, look at the near side on the left. Look at those massive craterings. Okay, and versus these smaller ones on the right. So, yeah, the water flows to the Earth side, more pole, more close to the Earth. Okay, and Mars on the moon, Mars. Okay, it means seas and uh, well, Latin, Spanish, and such. This is where the water came out. Okay. All right. So yeah, and it's all gray due to a lack of microbes. Okay, let's move on. Okay, the moon not from a melt. Okay. So where is the impact melt? Nope, 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 nope. Where is the dust on this boulder? Okay. This is what a lunar melted rock really looks like. Say over there on the bottom right. Okay. This whole idea of the moon coming from a melt, it just is not holding water. Okay, like that. These, yeah, these NASA photos from Apollo 16 and 17 missions are typical of the thousands of detailed photos taken of the moon's surface. Few of them show glass-like melted rock similar to the Weber glass on the lunar sample above. They actually did show a melted edge. The fact is, part of the reason that volcanic impact crater debate has gone on for decades and would continue indefinitely without new evidence from the hydroplanet model. On the moon, there are no volcanoes with lava flows like those on Earth, and impacts are very rare. Thus, neither theory can adequately explain the origin of the lunar craters or the rest of the moon. Furthermore, where is the impact dust on the boulder in the photo on the left? Many boulders have no dust or sediment that would be present if numerous impacts had occurred, as thought by impactologists. In the hydroplanet model, water present during the final stages of the moon's formation could have removed the dust and small sediment. Okay, so here's two examples of basically a surface explosion where you create glass. Like this is your impact, the picture on the right. That's what it's going to look like and happen with impact. Okay, on the left, you've got a slow speed underground explosion. Okay, this is low temperature, no illumination, no glass created. Okay, this is really great evidence here of the underground explosions creating these craters and not creating glass versus these glass creating high temperature uh, above ground explosion impacts. Okay. Um, so both of these explosions were nuclear, but the difference between them identifies the difference between impact type and phreatic or subsurface explosions. Okay, let me see here. Oh yeah, here's some more bullseyes, double impacts. So yeah, that's never gonna happen, but there it is, it happened. Um, and there's noticeable lack of ejecta on these types of craters, yet most researchers still assume they were made by meteorites. Okay, but now we know better. Okay. Um, yeah. Um, these double craters, see all those purple arrows? These double craters or these bullseye craters, they are not uncommon. They should be if they're just meteorites hitting, but they are not, and they're not uncommon. Okay, shows the interior genesis of that. Okay, so let's, and I'm hoping to get out of here before the 3 hour mark. We'll see. So water and meteorites not from a melt. Um, So let's take a look at, if we melt a meteorite, what does it look like? So you've got these globular, things. Um, so if they impacted at high speeds, like this is going to be going on more. But again, what we talk about is a lot of these are not from the source that people think they are. You've got these iron beads from the melted iron. Okay. Um, the melted metal looks completely different. The widely accepted origin of meteorites attributes them to the asteroid belt, which is assumed by the remnant of the magma planet core. Most meteorites show no evidence of melting, whether by impact or being magma planet core remnant. So, science has looked to these skies, the origin of rocks and minerals, but the answer lies at the bottom of the sea. Okay. The inclusion of aqueous fluids in meteorites. Water in meteorites, folks, have been found in a series of meteorites. This discovery was completely unexpected and still remains thoroughly enigmatic after years of studies. So, we got to remember, though, that all crystals in all terrestrial and extraterrestrial samples have grown from some kind of fluid. Said an article on fluid inclusions there. And so these guys, they're not from the magma. They're not from, a lot of the time they are made in these underwater diatremes and exploded out. And they have this terrestrial origin. So, yeah, look at how much water is in this meteorite here on the right. Okay, so the meteorite's 725 grams. The researchers discovered the water content of these types of meteorites is approximately 11% by weight, which translates to 80 grams, okay, of water represented here. This huge amount of water for this is a huge amount of water for any type of rock, but for a rock presumably from a once melted planet, this defies all reason and logic. Astonishingly, the water content of meteorites has been overlooked or ignored by almost all meteorite researchers. So you can see why I wanted to include this hydroplanet stuff with the magma pseudo-theory chapter, because this goes hand in hand, and um, you know by now we're seeing more and more of these evidences that, holy cow, this we're onto something here. H2O water tail and fountain, not fragments. So Halley's Comet, the first close-up encounter with a comet. Yeah, look at these tails of these comets. Okay, it always points away from the sun. As comets travel close to the sun, solar radiation and the increased gravitational effects of the sun and nearby planets cause water in the comet to be jettisoned, forming tails often visible with the naked eye. So this is gas coming off the comet, right? You'll hear that all day in school. Oh, gas coming off, gas coming off. But what kind of gas? That really brings it down to earth when you say, oh, gas is water. And, that's the primary gas, is water gas. And, they're going away from the sun because it's the radiation there. Okay, and Halley's Comet, you know, there's these, what we see here reveals clues about the inner workings of the coma. Ice was not melting on the surface of the comet, but rather hydro fountains of steam, water, ice, and dust were being ejected from identifiable hydro fountains in the comet. Okay, here's a large crater on Comet Wild 2. Okay, and there you can see steam explosions coming out of this comet. Now, when we've got so much water in all these comets, all these things were formed with primarily water, and so was our Earth, and they're made primarily water. Remember at the beginning of the lecture when I brought up that maybe the human body is another symbol analogy to this? If you just take some untrained kid and you say, how much of your body is water, kid? Like, I don't know, like maybe a cup of water. I drank a cup of water, maybe a little more because of, my blood has water, of course. well, and then you tell the kid, oh, well, kid, it's more like the majority. It's like 70 or more. Like I said, I don't remember, but you know, if what meets the eye, might not be what is the reality here. And I think it's a good analogy of some more discoveries here. Um, so again, let's look at this large crater on Comet Wild 2. Okay, so astronomers suspected that it would be a pile of rubble, all flying apart when hit. So they think that this was an impact crater. Like, seriously? They think that this was an impact crater. It would blast it to smithereens. Look at that massive chunk right there. You know? And, but no, that was an implosion from a water situation of a water fountain, hydro fountain. Okay. Hopefully that term has been sufficiently defined. Okay, racing to the finish here. Water in comets shows water origins. Okay. They found that the 72 trillion kilogram nucleus was extremely porous, with as much as 80% of its volume taken up by empty space. What was in that empty space originally? Did it just form with all these weird pockets? Yeah, it was water in that empty space. Theories about the volatile layers below the surface of short-period comets are going to have to be revised. Close quote. The more science studies comets, the more hydroplanet model is confirmed. Okay. Yeah. Now, here's a really cool where we tie it all together. Comets are thought to be frozen relics of the primordial material from which planets formed. Oh, so now if we're seeing all this water inside the comets, and that's obviously how the planets were. So bingo. Okay, so real asteroids aren't fragments. Okay, look at this. On the This is what an asteroid should look like according to modern science theory: heavy colored sharp edges. Real asteroids, okay, they're very porous and lightweight. They're rounded. Okay, there's no color, no microbes. Okay, this is photographed in 91. Okay, etc 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 etc. Yeah. These asteroids do not look like broken fragments of rock. Planetary scientists were surprised. These are the first close-up images of actual asteroids ever obtained. Okay, 91, and so forth. So the idea of asteroid, right, is this chunk that breaks off? Yeah, well, these don't look like chunks that broke off, do they? Okay, they're smooth, um, and they're lightweight. Okay, etc. Um, let's see here. Scientific American says, quote, asteroids have become notorious menaces, but are best appreciated in a positive light as surreal worlds bearing testimony to the origin of planets. Okay. All right. Yeah. Whoa, look at that. Large impact, right? No, that was not an impact. Okay. So, Mathild, I don't know how to pronounce it. Large craters like this have never been shown to occur from impact on a solid or fragmented body. Okay. It wasn't impact. What was it? Yeah, it was an implosion from escaping water. Okay, here we have more hydrocraters, not impact craters on Mars. Here you've got these water channel from a hydrocrater, hydrofountain ejecta. Okay, the Mars Hydro Valley evidence. Okay, this is a photo of about 26 kilometers, 16 miles across. It caused many questions for modern geologists from these structures. They thought these structures were collapsed lava tubes, um, but we've shown that these are actually channels of hydrovalleys, not collapsed lava tubes. Okay, so Mars, like the Earth, is a hydroplanet. Um, as we begin to understand these formations, so here we have a hydrocrater chain on the right on Mars again. Okay, non-impact. Yeah, it becomes increasingly obvious. Look at that pattern. Okay, these craters are unique in that they are elliptical and have some rim structure not found to be occurring today. These features refute the uniformity myth. So the big, the elephant in the room here is the Arizona hydrocrater. Okay, so this is where they get a lot of the estimates on the Earth's age of 4.5 billion years, calculated using supposed meteorites from the Arizona hydrocrater. How could this age be correct if the iron ejectites found around the crater never came from space? Okay, and then there's like a billion reasons here. So, no impact glass, no melting, insufficient residual. So this these are a bunch of evidences of why it's a hydrocrater, not an impact crater. Okay, no shrapnel meteorite fragments. The Widmerstatten pattern uh, establishes that the irons near the crater were formed at a low non-melt temperature as compared to the supposed temperature of impact. There's no embedded meteorites. There's two different forms of irons at the crater, meaning there would have had to be multiple impactors and multiple craters. That's not supported. The strewn field of iron fragments is not elliptical, as is shown with impact events. There's limestone at the crater, showing no evidence of heating, which would be evident from high-speed impact. No shatter cones were found. The amount of iron found in the crater is far less than the iron necessary to form a crater this size. There's substantial evidence of subterranean water. There's bisecting faults that lie beneath the crater. There's the shape of a diatreme, not an impact bowl, which is the crater's smoking gun. The crater lies in a volcanic district. Their shale balls are not meteorites. They form from iron ore and are found at the crater. There's diamonds, which are known to form only in diatremes. There's a significant deposit of pure white silica on the rim, and in drilling remnants at the base of the crater, attesting to the eruptions of subsurface waters. So there's a lot going on with this supposed impact crater, which is a favorite for the dating that we can chuck out the window. So here's some more hydro fountains, some anoxic environments preserving organisms in these blue holes. They're curiously round. So these are limestone pits. Why are they so round? Okay. Uh, Now, the carbonic acid is not appreciably eroding them today, and long-term erosion cannot count for the cylindrical form. These pipes are ancient hydro fountains created during the universal flood, a testament of the universal flood that modern geology has completely missed. And you'll read in the Bible, it says rains came, but it also says the fountains of the deep broke open, right? That's a big part that kind of gets, you know, glossed over. So yeah, there's other parts in where we talk about real cave formation and the how the acid theory doesn't really hold up. The waters aren't even acidic, and there's all these problems. But it's basically the same idea of this hydro fountain formations. Um, yeah. So here's a depiction of before and after the continent submerging with the crust collapse, mega fault, water flow, shooting all this up out of there. On the right, we have hydro fountains viewed from space along faults and plate edges, a depiction of what that could look like. We're talking massive hydro fountains. Remember the Enceladus one? Okay, and I'll say a flood comet triggers massive faulting and hydro fountain eruptions. The 5-mile deep worldwide flood is possible due to the hydroplanet. Again, remember, we can't just have water from the atmosphere. That would only give us about 1 inch worldwide. Now, firmament stuff, I'm not sure, but we're just going on what we can observe right now. So, again, scientists are beginning to agree that the dinosaurs died in a flood, in a flash flood, in a catastrophic flood. Okay, making common sediment graves with thousands of animals in them. So this is a neat point here on the Cambrian explosion, which is the mass extinction at the flood. So in this event, it was sudden, And they say we're going from lifeless Precambrian fossil rocks to the fossil-rich layers of the Cambrian. Was like walking past an empty lot on Tuesday and finding a fully furnished house in the same place on Wednesday. So long story short, everyone was happy, living life, but then the flood happened and an epic amount of fossils appeared. Okay, almost nothing before that. And then boom, there it is. So in this event that is so mysterious, the Cambrian explosion, 95% of Earth's marine species disappeared. And again, flood, water, why are the water animals dying? Because this is really hot water. And and it's moving really fast. It's going to tear them apart. 70% of Earth's land species disappeared. The mass extinction is linked to boiling seas. The event was the single most important event in biological history. There's no consensus as to what happened in modern science. So, again, these fossils are only formed in a flood hypertherm. Sudden mass deposits of fossils are evidence of the flood. So again, we know there's liquid, but is it water or magma? So the S waves, yeah, travel only through the solids, making the shadow zone on the opposite side as of proof of the shadow zone showing there is a liquid there. It won't travel through a liquid. That's why we don't see it showing up on the other side. The continents are floating on a flowing substance. So one analogy is Swiss cheese with all the holes in it, right? It's got water and rock flowing through deep in the earth. Okay, think of the earth like a Swiss cheese. The inner, yeah, moon made out of cheese after all, right, folks? No. But that structure can be going on a lot more than we think. Inner core, solid ice, high pressures, low temperatures, water remains solid. Okay, equatorial bulge. Okay, that's a little review. Let's race here. Planet formation. Okay, the planets. Yeah. Let's race. Okay, one or two things. So remember in Genesis 7, it says the high hills under the whole heaven were covered. The waters did prevail and the mountains were covered. Okay, this is a big flood. Where'd all the water come from? Okay, the continents were able to buckle under. I think I have a map. No, I don't. So basically, flood comet passes by. It throws off the Earth spinning around is making a centrifuge that pushes the rocks, the continents up to the surface. And then when that gets slowed down from the comet passing by, those aren't being pushed up as much anymore. It's like when you throw a bucket of water, you have a bucket on a string or like a pail with a handle, and you swing it over your head. The water stays in because of that force. But if you slow it down, it comes out. So that's the analogy here. You slow it down, the continents can go down, okay, in all this water. And the crust breaks, and boom, everything's going down. So again, Genesis 7, all the flesh died that moved on the earth. Every living substance was destroyed upon the face of the ground, and the waters prevailed upon the earth. 150 days. The water planet makes the flood obvious. We could get into this stuff. I think I said I was going to try to cut it off around 3 hours, so we're about there. So suffice it to say, we can account for the pedestal mysteries, Monument Valley, okay, all this stuff from basically a bunch of little uh, water hydro fountains and solidifying in hydrotherm while other stuff around it eroded away. Okay, there's a picture of your hypertherm going on, 30,000 feet, 14,000 psi of pressure, 400 degrees Celsius. Okay, sand being formed in the hypertherm, we talked a little about. Obviously, that's an epic conversation to have another day. The arches, okay, there's these water flowing through, and if the arches were eroded slowly as they say they were, why? Where's all the debris? Well, it's not there, and there's not evidence of rivers taking it away. So what happened was they were carved out during the flood and taken away at that time. Okay, on the right, you see these different colored mounds. Why is this happening? It's not forming this way today. It's not just erosion doing this. These are different color sediments from different depths of the Earth hydro fountains with different microbes that leave their mark. Again, doing a little bit of racing here to the finish. Okay, caves, real origin of caves. Microbes, not acid, created the cave formation. Carbonic caves are not growing. They are growing, not eroding today. Carbonate caves were formed shortly after the sediment was laid down during the universal flood by aquifers that ran through the sediment. Then the carbonate layers hardened during the universal flood hypertherm, preserving the voids in the rocks. The beautiful formations then grew from microbes, not by redeposit of dissolved carbonate. Here's this really cool White Sands National Monument. Where the blazes did that white sand come from? And if it was transported from erosion from a mountain from somewhere, where's the river transporting the gypsum sand from the mountains? Okay, these didn't come from erosion from a mountain. It came from hyperthermal mineral deposit created in the flood. Okay, again, back to the fountains, spraying out this stuff. And so yeah, also rain over millions of years would have dissolved the gypsum sand crystals. So this is another evidence that it wasn't millions of years ago that this was deposited. It was just several thousand years ago in the flood. This is a whole nother story. We can produce synthetic coal. A couple fossil things. Here's your diagram for your... I'll braze over this. You can pause the video and check this out further if you wish. But I'm past 3 hours now, and I'm just anxious to get out of here, honestly. And you are too, I guess. So yeah, pre-flood, flood begins, burial, fossilization, erosion, and here we have today. Okay, and then this talks about the centrifuge slowing down and submerging continents, where then the fountains open at plate boundaries, which then you've got your hypertherm with the 30,000 feet. And then then the rotation rate increases, floodwaters recede, the two forces come back into equilibrium. So again, you've got dinosaur egg fossils. Eggs are soft. Why did they turn into rocks? This was not a normal situation. You've got footprint fossils. That's usually not something. You've got water ripple fossils. Okay, you've got this very fast, sudden event that's creating all this. And the most common fossils are these petrified wood, and they're everywhere. And so why the wood? Why is that one of the most common? Well, that's pretty obvious that it was a surface event. Now, these are close to the surface. They're not, there's not in a bunch of layers of strata. Okay, and the scientists are admitting these eggs were smothered by a flood. Talked a little about that. Another thing is a lot of sediment that we think is erosion sediment. There's missing sizes. If it's just erosion, there should be all of those sizes, but it's there's a lot of missing sizes. So the sediments were not from erosion in the first place. They were made that way, of those various sizes. And that's why we don't have those missing intermediate sizes. In the Grand Canyon, you've got all these missing layers of geological deposits. Okay, oil, soil, coal, lava flows, coral reefs, salt. You've also, okay, so this is the idea that the Grand Canyon was not put down in these many layers over a long time. Okay, it was made in a short time. Okay, universal flood deposits these layers, and then an earthquake opens the Grand Canyon and reveals it. So how could all these layers of sediment have been laid down over millions of years and have no organic layers between them? So if there was a little layer here, wait a long time, another layer there, wait a long time, we would see lots of organic intermediate layers. Again, the oil, soil, coal, skeletons, etc. There's little to no skeletons in the Grand Canyon. There's some tiny things. There's not yeah. So this Colorado Plateau in general. This is flood deposit. Basically, the surface of the Earth that we see now is completely different than before the flood. The very interesting point here is that there's multiple layers of organic soil that have there are no multiple layers of organic soil. You can see in the middle picture here, there's only one layer on the surface. There's no multiple layers of organic soil. Okay, a couple things about weather. So we talked a little about the piezoelectrics and the geofield, predictable earthquakes, earthquake clouds. I'm going to skip over some of this. El Nino and La Nina, we don't have time for that either, but suffice to say, it's not just a annual thing. It's a result of a longer cycle that includes lunar Earth tide heating, and there's like at the same equator, you've got colder and hotter water. These El Nino events are not caused by global warming. They're also not caused by the sun. There are earthquakes underneath the ocean crust with heat and pressure systems that create plumes of hot water that rise to the surface and create global weather patterns. So, we talked about that. Coastline auroras. So they have a hard time explaining these. Auroras are generally the brightest where the geofield is the strongest, as seen in these images, and that is over the continents, not the oceans. I'm going to breeze through this too. Okay, frequency of lightning strikes, check that out. It's over the continents. Why? Oh, that has more to do with piezo fields and electric buildups with the piezo fields where the crust is. Just breeze through that, breeze through that. I'm going to breeze through that. Oh, this is a really good point, but gosh. Let's see here. I know we're close to the finish. Let's see here. Good enough. We're just moving on. Yep, moving on. Okay, here we are. Here we are at the end. So, in review, if there's no magma, there's no millions of years. Magma defies heat flow physics, and radioactive magma doesn't happen, and quartz is not glass, and natural rocks are piezoelectric and thus not from a melt. And remember, as in the days of Noah, so shall it be when Christ returns. So this, lots of evidence that the another comet coming our way to really shake things up. So good time to be saying your prayers and getting right with the Lord. Let's see here. We also have scripture that the continents will recombine, so that's cool. Let's move on here. Yep. So again, back to where we started with the fire god versus the water god. So now you can have a little more background of how the magma earth basically is a way of saying there couldn't have been a flood. The earth is super ancient. There's radiometric dating and evolution, that we're accidents, insignificant, no God, no Christ. Everything's death and eternal entropy and depression. And it's all based on fairy tale science. And then we have the real history of the earth, the real science, which is the water earth, easy flood, plenty of water to do the worldwide flood. The earth is young. The Bible's dating is the correct dating. The earth was created for a purpose. There's God, there's Christ, there's life, there's resurrection. Science that we can demonstrate. And please make sure you go to universalmodel.com to get a copy of the full text. There's Universal Model Volume 1, and that's where most of this was from. There's some of it from 2 where the fossil model is, but the flood as well as the magma pseudo-theory and the hydroplanet are in Volume 1, so check that out. You could download this presentation if you'd like for free at richardsonstudies.com. This is Nate Richardson, and that's that.